and healthy. I think we had a good conference. Can we clap our hands for the conference and the organizers, and the organizers, and the organizers of the conference? We had also our Inspector General here, who graced the thing. And I think our minister and the DG, they gave it a blessing, even if they were not here, but they gave it a nod. So I have a task for this morning, and I believe I'm going to enjoy it. I have about 3 speakers, astute speakers. I've got very good speakers for you here. Mr. Jack Davi. Mr. Jack Davi, I guess if I remember my cue very well, from my director, Jabulile, I guess that Jack Davi will do 2 of the presentations, meaning that Mike won't be there. Okay, no, that's fine. I think Mike and Jack must have spoken between themselves. So Jack is going to be doing both presentations, but Mike will come in between. Well, in terms of the profile and the resume for Jack started his working career in the Navy. He started cutting his teeth in the Navy, exiting as a technical officer, having gained extensive experience in the life support equipment, workshop, and fire training center. Finally, overseeing maintenance and procurement of safety equipment. I think we're going to get a bit of that this morning. Currently, Jack is working as a quality health and safety advisor to the offshore oil and gas industry. What a title, what a responsibility, huge responsibility. Offshore, it means in the waters, isn't it? Offshore means in the waters, deep in the waters. And we know that the water is bigger than all the continents combined. So it's a huge responsibility. Currently working as an advisor to the offshore oil and gas industry and a member of the Special Technical Committee on Gas Test Stations. Now he begins to get right into my heart, because that is my backyard. And he's also on the Pressure Equipment Forum, which I chair, and he's also at the SABS TC58. TC58 is the top-end technical committee for all pressure equipment regulations, pressure equipment standards. So you can see that Jack is actually there with the upper ups and the Joneses, responsible for pressure vessels among the most pertinent. Well, Mike will be coming in between. I guess that you have discussed that yourself. You don't know that Jabu will... Jack again. Okay. So we'll get Jack, then we'll get... yeah, JJ. We'll get Jack Davi, and then thereafter we'll get Mike, is it Mark Giles? Isles. Mr. Mike Isles, and then we'll then revert back to Jack. Mike Isles has a Bachelor of Technology degree in Mechanical Engineering. He started in the Marine career, same as Jack, in the South African Navy. Oh, they must be good friends. training to be a marine engineering officer. In the year 2000, he entered the commercial diving sector, and shortly after that, assisted in the founding of the Unique Hydra. He'll tell us more about the Unique Hydra. He has 25 years' experience in the design, manufacturing, commissioning of commercial and military dive systems. Mike Iles currently holds a position of Country Director at Unique Hydra and Unique Group Company. Ladies and gentlemen, would you join me in giving a hand clap and welcoming Mr. Jack Davey? Over to you, sir. And there's a small little gadget for you to use.
Thank you very much, and thank you very much to all the organizers for this venue and the opportunity. When I was asked by the department to do a little presentation on the regulations, especially the pressure equipment regulations, giving in a half an hour, it is not that easy to cover all the aspects. So during this half an hour and during this session, I'm going to focus on something and try and relate and show everybody how everything ties together, what our responsibilities is. And again, this is just part of one of the regulations that we all need to apply in this industry. It's not that easy. What we need to know is our side of it is very small in the grander scheme of thing, in the grander scheme of in the country, of all the pressurized equipment there. So for us, the focus is quite high on what we do. In the maybe all the pressurized equipment in the country, it's a very small part. So in terms, as I go through, a lot of it is through the legislation, the acts and the regulations. It's very important to understand, this is not necessarily my views, but it's what's written on paper. I might not agree with everything because of the fact and because of what I just said. We have to look at how does it best suit the needs of the country and everything. We can't write documentation and legislation for every specific piece of equipment that there is. It has to be in the scope of that. And we have to, as an organization or as bodies, we have to look at how do we implement it and how do we fine-tune it to our needs, working in that broader scope. Bit slow today. Sorry about that. Okay. Just for everybody to see, this is how everything fits together. We're starting with our Act, which is the rule of law. Through that, the Act just tells us what we need to do. The most important through that is the various regulations, which you can see on either side. We're having our electrical, our general machinery, all those type of things. What I'm going to focus on really is the pressure equipment regulations here, and as you can see, the diving regulations, which then refers to specific standards again. From the regulations, we got our standards, and what I would like to see to you from the Act, it tells us what the purpose of the Act. In the Act as well, Regulation 44, incorporation of health and safety standards. It's important to understand, SABS has got a magnitude of standards worldwide, everywhere. A standard is a reference document. That document is a nice to read unless it's referenced by an Act or regulation. And this is where we're looking at Clause 44, Regulation 44, incorporation into the Act. So the standards that's incorporated under the Act and referenced in the Act becomes law and part of the Act and the regulations. If we look, standards specifically covered by the pressure equipment regulations and reference, SANS 347 for the categorization. You can see the scope of that, so it does apply to pressurized equipment in what we do, in what we use in the diving industry, as well as SANS 10019. Not only is that referenced in the pressure equipment regulations, but that standard is also referenced in the Code of Practice, Diving Code of Practice. So it is there, it is referenced, so it becomes a compulsory standard that you have to abide with, that we have to abide with. Again, the scope will tell us what to do. It's transportable pressure equipment from 0.5 liters to 3,000 liters water capacity. As well as if you look at clause 1.2, it says, in addition, it will cover self-contained underwater breathing apparatus for scuba and SCBA, and in the absence of where specific areas are addressed in the diving code of practices, or in the terms of the military diving, SANUP 96, this standard will be applied and has to be followed. So if it's addressed or there's a gap analysis being done in the code of practices, that is where it can be addressed. Otherwise, the standard, SANS 10019, has to be followed. Sorry. Okay. If we look at these standards, how many here, because we're working with it, because it's compulsory standards, how many of us here has actually got copies of the latest revisions of those standards that we can reference? Both the training facilities, the manufacturers, the contractors. How do you know what you need to reference if you don't have the latest? If we're starting with our pressure equipment regulations, we look at the scope. Again, we say it applies to design, manufacture, operation, repair, and modification, maintenance, inspection, and testing of pressure equipment. So it applies to everybody in this room, not just the manufacturer. It applies all the way down to the end user as well, the person using the equipment. Going through a couple of definitions, which is important. If we look at a gas system, it's an assembly of tubes, pipes, similar ducts, fittings, and valves. And I always struggle with this one, the reticulation, circulation, and conveyance of gas, excluding pressure vessels. So in terms of this, if you have a filling station, if I can use that, and I'm going to use the reference to cylinders going forward, is if you have a filling station, filling cylinders, everything there is your gas system. Your storage banks connected to that doesn't fall under the gas system. It's separately addressed. Pressure equipment, again, is the whole system put together. And again, it includes safety accessories, transportable gas containers, and hyperbaric chambers. And the topic that I'm going to take through, the one that we all know, it seems simple. It is a bit more complicated than what it just is. We all know what a cylinder looks like. We all know the different sizes. It comes in, and that is what it is. So your transportable gas containers has the same meaning as the term pressure receptacle as defined in SANS 10019. So we're going to use that to trace it through the standard. I cannot go through the whole pressure equipment regulation. It will take us a whole day or two to address everything. So I'm going to use this as specific just to give you an idea and an overview of how you need to look at the integration of the various regulations and the standards incorporated. If we look at the scope, so we've determined, we've looked at it before, the scope of the pressure equipment regulations does apply to it in its entirety because we use pressurized equipment. General requirements, so this applies any person who manufactures, so that's the manufacturer, importers, sellers, or offer or supply of any pressure equipment described in these regulations for use in the Republic shall ensure that such equipment complies with this regulation. It's not a question of can it, may it, it is you have to do it, you have no choice. And you have to address it. You might not be 100%, but then there is the communication channels, incorporating it, making changes to the relevant standards, and incorporate into it. Address it. It's part of the risk assessment. It's part of your decision. Have you identified where your problems are? Again, duties of the manufacturer. This is very important. We've got manufacturers here. We've got people bringing in equipment. We're bringing in equipment. We all know the likes of the Kirby Morgans. They aren't manufactured in the country, so they have to be imported. Where you bring it in yourself, where you buy it through an agent. Those people are responsible. So the manufacturer shall have the obligation to ensure that all equipment designed and manufactured for use in the Republic shall be conformity assessed and inspected to the requirements of SANS 347. So here again, it referenced SANS 347. So it needs to be done with that. Subject to requirements set out in the relevant health and safety standards, incorporating to the regulation. Again, there you can see is now it referenced the standards. It tells you that it empowers the standards to become enforceable. If we look at subject to requirements of the regulation, manufacturers comply with any other duties assigned to the manufacturer in the regulations. And then it says this, you have to have a certificate of manufacture for any pressurized equipment. Whether you import or manufacture it, and it has to comply with the regulations. The certificate of manufacture must declare conformance to the pressure equipment regulation. Now, there's a lot of equipment being manufactured internationally in the CE, and they will come in, if we look at cylinders, they'll come in with a CE declaration of conformity. That's not a declaration of conformity in terms of the pressure equipment regulations. That is just a substitute or a contributing document that you can add to your determining your own declaration. You as an importer or manufacturer have to ensure that that conforms. You have to do a conformity review, make sure that it conforms to our requirements, local standards. Now we're going to the importers and suppliers. Very importantly, the importer will or shall assume the liability of the manufacturer. So you can't say it's been manufactured by somebody else. If you import it, you take that liability and ownership of that piece of equipment. So be aware, be very understanding of what your duties are as an importer. You can't transfer that. Again, the importer in this entity, which imports pressure equipment for use in sale in South Africa, he must be under the jurisdiction of South Africa. That is so that somebody can be held liable and accountable. Second one, highlighted, the import of pressure equipment into South Africa assumes the liability of the manufacturer, we said that, and where users or their agents appoints entities. So if you appoint an agency to do it for you, they assume the liability of the importer into this country. So make sure you understand all of this, and this is what that's really important. Again, if you look, permits reference, where users, the permit reference in PR53 is applicable to fire extinguishers. So under certain conditions, cylinders imported into the country, transportable containers, require a permit. At this point in time, it's only applicable to fire extinguishers and LPG cylinders, nothing else. There is a concern, and it might change in future, but currently this is a stand. So make sure that you have cylinders imported into our country. For everybody here, you do need a local declaration of conformity by the importer, having analyzed and having assessed that it conforms to all the different requirements. Carrying on, there's a lot more to say. You can see these. It just tells you the obligations and the importance of that. Now we're getting to the user. The user is not absconded. So the Act and the regulations addresses the users as well. So the user can't say, I'm giving it to the importer or somebody else is responsible. It says the ensure pressure equipment has a certificate issued by the manufacturer, including a verification signature by an approved inspection authority when required. Under certain circumstances it's required, under others it's not. So make sure of that. How many here in this room, majority uses cylinders? How many here have got the manufacturer's certificate for their cylinders that they're currently using? Copies of that. So that is not that many hands that I can see. If you don't have it, not me that says so, not somebody else, it's been written in the regulation. So make sure that you have it. I know some of the older cylinders, it is difficult to get. If you see your importer, your manufacturer, it's their obligation to provide it to you. It's your obligation to maintain and keep it for the pressurized equipment that you have. And that goes for all your pressurized equipment, not just for cylinders. I'm just using the cylinders in this example so we can follow the same thing through the whole presentation. Gas containers. No user shall use, require, or permit a transportable gas container to be used, and no user shall fill, place in service, handle, modify, repair, inspect, or test any transportable gas container other than in compliance with the relevant standard incorporated into these regulations under the Act. So you're looking at SANS, especially in this case, it's SANS 10019, and then for the testing and inspection it's 1825, SANS 1825. You have a duty. Yes, you can send your cylinders for inspection and servicing to approved gas test station. We're talking about how do you get that, where it comes from. You can do that, but you need to make sure that those people that you send it to comply and knowledgeable. You still have a responsibility in the whole process. You can't just go, but I send it to somebody, it's not my job. For years and years, anybody can test your cylinder, and I'll talk in the next presentation, I'll talk a little bit more about that. Anybody can test it. everybody says they can. Everybody knows they can. Even in the IMCA requirements, it says the dive technicians can do that. However, in this country, there's a specific requirement that it has to be accredited test station and then approved by the Department of Labor. The moment you don't test it by anybody else, it means nothing. You have wasted your money and you've exposed yourself to litigation. Then just a note for interest sake, and I know there's a lot of questions, I get asked a lot of questions on that. On containers or pressure systems, on little inflation devices, that's less than 0.5 liters. Now the regulations and the standards only go from 0.5 and higher. It still says, although it's not covered in the regulation, it shall be manufactured to a relevant health and safety standard, so an approved standard. So although it doesn't specific, you need to ensure that. So that puts the onus back onto the end user as well. If we're carrying on, as we follow through, so that's where in the pressure equipment regulations where it talks about cylinders taken out. If we now go through to the next lower standard, which is 347, I'll go through that a little bit and show you where we go, carry on from there. Categorization conformity. So this is where you do your conformity assessment. Whether it's your panel, whether it's your pressurized equipment, whether it's your compressor, your filling system, it has to fall under this. Now it doesn't have to be complicated. It's as complicated as you make it. But you need to understand it. And that's where it's going through. It's reading the regulations, it's having discussions with each other, soundboarding each other, and coming up with a solution that best works for you. Not every system is the same. And that's why I picked cylinders to pull it through. Because it's as simple as an entity. You can't do many things onto it, and it's addressed in its entity by itself. The rest of the things we're going to ask, but what about safety devices? What about this? What if the hose diameter or the pipe diameter is this? What if it's made by this? What is the pressure rating is this? It makes it complicated. You have to review those as a system by itself to come up and see through the standards regulations, how it fits to you. So that's why we're using cylinders again. So this applies to everybody. Definitions again, approved inspection authority. That's somebody that's gone through an accreditation process, either 17020 or 10227, as an either AIA, so in terms of pressure equipment, classification and certification. So for them, that would be approved inspection authority under the PER, LVUP. Or for gas test stations, that would also be the same. So they get accredited by SANAS, independently review their management system. Then once completed by that, the Department of Employment and Labor will review that, and they will give approval for that test station or that AIA to operate for 4 years, on a 4-year cycle, with regular assessments through the accreditation body. After 4 years, they have to go through the whole cycle again and apply again. So it's reviewing their management system, looking at their procedures, looking what they're doing, making sure that they can do what they say. That accreditation will also look at giving them a specific scope of application. They can't just do anything. It has to be on their scope what they can do. So it's your duty to make sure that when you pick a gas station, that you go look on their schedule of accreditation, what they can and what they can't do. People will tell you they can do anything. They will do it for you, and on their certificate, they'll remove the SANAS logo or they'll remove the Department of Labor logo. They've done it for you. The same happens for calibrations. Some people will tell you they can do it, and they can. They might not just be accredited to do so. And if it's not accredited and accreditation is required under the law, you are in non-compliance. So make sure that you understand and do the right thing. Certificate of manufacture. It's a written declaration of conformance to the relevant health and safety standards and to the relevant national legislation. So that is, again, the importer or the local manufacturers, they declare that the equipment conforms to the pressure equipment regulations, the Act, and the relevant standards. Declaration of conformity conforms to either applicable health and safety standards, applicable code symbols, markings, or relevant European directives. So criteria for determining, and I've just taken the most important out of it. So in order to determine which category an item of equipment falls into, the manufacturer shall identify the following. So it's important, identify where it falls into, and then you can go through the different classes. So we're going, is it a pressure vessel? Is it just piping? Is it safety accessories? And then number 6 in the list, transportable gas containers. We're working with cylinders, so we're picking that one. Okay, transportable gas containers. It is in this. It needs conformity assessed. If we look at B, the state of the fluid, gas or liquid, and you're looking at the notes, or what group is it, group 1 or group 2, and then it tells you the tables. I've added the tables. If we look at column 11, it tells you transportable gas containers. It's got a note, and it tells you transportable gas containers and their safety and pressure accessories shall be assessed using table 3. If we go to table 3, this is what you assess it against, and making sure that it conforms to this and then the relevant standards, as we will go a little bit further. So it's already there. Different categories. It tells you where it is, whether it's a SEP, sound engineering practice, category 1, 2, 3, or 4, and it tells you where, excluding transportable gas containers. So transportable gas containers has got its own section where it needs to be assessed and looked at. General, before putting pressure equipment classified as either hazard category 1, 2, or 3, or 4, remember we looked at the table, compressed gas cylinders, category 3, into the market. Such equipment shall be subjected to procedures in the appropriate conformity assessment modules in accordance with either table 2, 3, or annex B and C as applicable. So it tells us, it's straightforward. You just need to isolate in the regulations and standards, look at it, put what you're dealing with, and read it in sequence. Final assessment, pressure equipment shall be subject to final assessment, manufacturer described in those clauses. Approved inspection authority shall also carry out a final assessment in accordance with conformity assessment as applicable as required. In certain instances, under the pressure equipment, I'll get to there now, the regulations and requirements, you do not need an AIA. The importer can declare their own conformance to the national requirements. Final inspections, pressure equipment shall undergo a final inspection, so that's where it's visually inspected, pressure tested. You may use the original manufacturing. If you've got the certificates, you may use that where they've indicated that pressure testing has been done on all the cylinders, the initial pressure test. So you may use that in these terms. Conformity assessment. Final assessment, pressure equipment shall include the test of pressure containment aspects, will normally take the form of hydrostatic test, as I mentioned. Now, very important in this one, if it's a DOT spec or a pi mark cylinder, the importer themselves can declare, conformity to the standard. If it's not, you need an AIA to do a conformity assessment and countersign your declaration of conformity accordingly. At the moment, I've just left that, so we've got dealing with pi mark, we're dealing with DOT, and we're dealing, in the latest update of 347, they've added ASME, API, and CE, as well as the row marking. Although it says it's recognized, the way the standard is written, I know through the last meeting, the discussion was that it will be applied the same as the DOT and the pi mark. It's just not written that way. So you have to, when you read the standards, when you read the regulations, you have to read what's on the paper, not on what you think or your interpretation. Read what's written. The standards and the legislation has changed so many times, and we as humans are lazy. We read the first 5 words, it looks familiar, and we skip the paragraph, we carry on. Things have changed, might be changed. The last sentence, the last couple of words might be changed. It might have changed from should to shall. It might have changed from may to shall, and you missed that, and you missed that. So read, whenever a new one is, read it, highlight it, make notes, get the paper copy. That's where electronics is not that great. Make your notes, make the differences, look where they are. Luckily, it's easier to make the changes and show where the amendments are. If we're now following through to SANS 10019, we're going on, very important. So this will tell us the scope, so we know 0.5 liter to 3,000 liters, and the pressure. So we're good there. We know it applies to all of us using either our bailouts or storage cylinders as such. 1.2, in addition to industrial, refrigerant, medical, and domestic, as I said before, it applies to scuba, ACBA, and the previous one, if you remember, 8, revision 8, they made a mistake. It said it excluded professional diving. They omitted something. That was corrected in revision 9. We're on revision 9.1 at the moment. So it does conform to you. If you need to address or be more stringent or get better at something, address it in your relevant code of practice. And that's where it's important. Make sure that your code of practice don't say you have to comply with the standard blanketly, and then you use conflicting information between your code of practice and the standard. Design, again, it tells you what we need to design it. The preferred standard given in Table 1 do not preclude design, manufacture, and use of pressure receptacles in accordance with the following. So it will tell you you can only bring cylinders in that is currently being manufactured to an approved standard or current standard. If it's a withdrawn standard, you cannot bring it in anymore. And there's a lot of confusion around that. If it's a withdrawn standard, you can still use it until it fails its inspection. Again, we said only pressure receptacles that in respect of basic design manufacture comply with the appropriate and relevant requirements of this standard, together with the standards approved by the relevant national department, shall be allowed for general distribution in South Africa. Refillable pressure receptacles that are not accompanied by a manufacturing certificate of construction and certification by an approved inspection authority or a certificate of recertification used by a test station shall not be allowed for distribution in South Africa. It brings me back to my previous question. How many of you have got manufacturing certificates for your cylinders? New pressure receptacles shall not be manufactured in accordance with local, regional, international standards after the indicated date of withdrawal. Bearing in mind, there is a little bit more to it. When you manufacture, your factory will get a type approval certificate. That can be extended until past the withdrawal date. They are still allowed to manufacture them up until the withdrawal date stipulated in type approval. So if you're bringing cylinders in, argument's sake, you need a manufacturing certificate. You need ask them, get a copy of the type approval certificate as well. That type approval certificate is particular to that specific factory. If we look at, let's say, for instance, Luxfer. Luxfer's got factories around the world. You can't take a certificate from Luxfer in one country and apply it to another factory in another country. It is for that specific factory where that specific cylinder was made. And that type approval is only up until that point, where it's stipulated on the type approval certificate. Permanent markings, it tells you what shall be on the cylinder. You need to maintain it as a filler. The test stations, they, however, will look for other information, additional information to look at. Identification, certificates, manufacturer or local importer repeater shall keep and make available. So the importer shall make available. In this industry, we do have a problem with importers, all the importers that no longer exist. A lot of things are hydraulic. So if you do need to get copies from the manufacturers, they have to go through archives. They are going to ask you for remuneration for that, for their time. And they might not deal with the end user. They might only deal with the person that imported or the entity that imported. So it does make it a challenge and a difficulty. Revalidation, we spoke about it. In SANS 10019, the SCUBA and the SCBA was moved up to an annex, addressing it. Any deviations from the regular part of it? Because remember, SANS 10019 covers the industrial. Our industry is maybe 2% on cylinder size in the country. So we have got this one as Annex G in there, addressing discrepancies or deviances from that, where we need more stringent or more clarification or better control because we're dealing with human lives and we're dealing with harsher conditions. 1825, I'm almost done. This is the inspection, just so you know. And we're stuck again. Again, the scope, this is for the test stations. This is what they need to do. This is what they look at. Records and inspection certificates. Sorry. So, very important. If your cylinder doesn't have a manufacturing code of manufacture, that cylinder has to be scrapped unless you can provide the test station with a manufacturing certificate linking that to your cylinder serial number and the dot on it, at which case they can stamp it on and put it back into service. Just for a heads up, what we have done during the period of the BS 5045-1 saga, where the cylinders came in, I did a list and I consolidated a lot of cylinders, certificates, manufacturing certificates, that is available in this country. You can see it, you can follow the QR code, it will take you to that, you can use it, that's the information on that, based on the manufacturing date and that. That is a purely voluntary system. It's people supplying when they get certificates, they add to that, so it makes it easier for everybody to see what certificates is available in the country, so that you don't waste your time to go look for it and engage the manufacturers. Because remember, batches are manufactured in up to 2,000, 3,000. If 3,000 people individually starts engaging the manufacturers, they're going to get tired and they're going to get antsy and they're going to not start supporting. So it is available. Those ones are there. We've got a mailing list on the standards, particularly pertaining to 1825-10019 that I maintain. If you are interested, send me an email. I'll put you on that mailing list. So if there's any changes, any updates, I will add you to that. And that brings me to the end of my first slide. Thank you very much for the opportunity again. And if there's any questions, please keep them.
Well, thank you so much, Mr. Davey. Can we give a round of applause again? Very, very valuable. It's not a piece. It's a chunk of information. You need to digest it slowly and surely. But thank you so much for giving such a beautiful presentation. Ladies and gentlemen, before I call Mike, where's Mike Iles? Yeah, before I call him, and sorry about that, but I need to do this. You see, in the Department of Labor, when we are here, our inspectors are out in the field, in different places, the whole of the country. So they make sure that even when the minister is not at the workplace, he is there even in her absence. When the Director General is not there, because the inspector is there, the Director General is there. The Inspector General, the Chief Inspector, the directors and the provincial chief inspectors, they are represented countrywide by our inspectors. And that is why I'm going to make this very sad announcement about one of our inspectors that passed on last night. We have an inspector, his name is Obakeng Muremedi. Obakeng Muremedi. Obakeng Muremedi was sick. He was an inspector in one of our labor centers in Kuruman. As I was sitting down there, I received this sad news, and the person asked me, is it something that we can announce here? I said, of course. It is one of our own inspectors that has been doing studying work, and he just passed on last night, and it's very, very sad to make this terrible announcement, because this young man, there was still more for him, and most of the things that we're talking about here, he enforced the legislation, he enforced the regulations, he enforced the standards. So we said, can we just, by way of standing up and observing a moment of silence, let's all stand up just to honor the life of Obakeng Muremedi, the life of Obakeng Muremedi. Yes. A moment of silence, please. Well, thank you, ladies and gentlemen. May his soul rest in peace. May his soul rest in peace. Yes, before we take Mike, it is very, very important to understand what was presented here previously. As a Department of Labor, we enforce the legislation, but we also accommodate other international standards. South Africa is unique in its own position, in that we don't only enforce our legislation, national legislation, we also acknowledge, like legislations some in the US, some in the European Union. And that is why you'll hear about the U-stamp in the PER, and you'll hear also about EN standards in our regulations. Our schedule of standards is quite huge in the PER. So we are quite unique in our own way as we make sure that there is safety across the board, and especially also in this industry of diving, commercial diving. There is enough standards, enough regulations to make sure that our divers are safe. In as much as they're making lots of money, yesterday somebody was telling me that these guys go into the sea maybe for about 28 days in the water. And in a day, one of them could be making anything between 18 and 20,000 a day. But they spend time, about 6 hours or 8 hours in the waters. It's the risk that they take, and there is payment to that regard. But these are very, very scarce skills that are taking place. And South Africa also licenses people outside South Africa. We are a very, very flexible country and a regulator. And the issue is that CISBULI, we are very, very cheap. We charge in rands, and people make money in dollars. Well, thank you so much. Mike, are you ready for a take? That's your time, Mike. Clap your hands, yes.
Thank you very much.
Oh, thank you. Sorry, Mike.
Good morning. I've got the mic. Good morning, ladies and gentlemen. Just to introduce myself again, I'm Mike Howells, Company Director at Unique Hydro. And Unique Hydro is a manufacturer, and I'm very aware this morning that I'm going to be speaking on operations. So I would ask you to just go lightly on me, but I'm going to give you a bit of an angle from operations and lifting operations from both sides, operator side and the manufacturer side. So without further ado, let's proceed. When we talk about lifting equipment used in commercial diving operations, just to give us an idea of the equipment that we're talking about, launch and recovery systems for our surface and closed bell divers. And this is often forgotten about. It's the tool that takes our divers to work and back every day safely, used probably the most in lifting operations. We have cross-hauling of bells, which is required for operations, normally deep sea and saturation diving. Rigging equipment, which is a very, very broad term for a hang of a lot of equipment that we use in the underwater industry. Underwater airlift bags, launch and recovery systems for remotely operated vehicles, and then the cranes and the lifting devices that are actually on the vessel that is assisting the job. Unique Hydro manufactures a great deal of this equipment in Cape Town, in Epping, and our Unique Group manufactures several of the items that you see on this list around the world. So I'm just going to show you a short video just to give an idea of what some of this equipment looks like, and from a manufacturer side.
Our seas and oceans constitute a world we know little about. For decades, we have navigated these uncharted waters with you as we continue to imagine and innovate new solutions. We are Unique Group, innovators in subsea technologies and engineering. Our mission is to look beyond the horizon of possibility and give you the tools to go there. With advanced autonomous technologies, you can carry out safe and reliable survey operations in the toughest operating conditions. We offer a best-in-class portfolio of survey and inspection products, along with technical advice to support your projects 24/7. Our high-quality inflatable buoyancy products and load-testing water weights are designed and manufactured to make your projects safer and more efficient. With our state-of-the-art commercial diving and life support equipment, make your diving operations seamless and safe. We deliver quality projects safely, sustainably, and successfully all over the world. We are committed to creating value through responsible operations for ourselves and our clients. We are Unique Group. Explore our capabilities and discover your possibilities. And together, let's propel towards an extraordinary tomorrow.
Right, so if we dive into lift-in operations, there's some key steps to have a safe and a successful lift-in operation. And I'm just going to touch on these points very lightly. We need to have an effective safety management system. And this is really key, and it starts with our senior management. We have to have it built into the culture of our organizations that we have good and effective operating procedures and practices within our management system. We need to do good planning. We need to plan well. We all know that we plan our dive and we dive our plan. Well, we need to plan very well when we come to lift-in operations. Risk assessment is essential. We need to look outside of what we often consider the norm and think what would be the abnormal, where and what in the surroundings can put a different aspect on the lift-in operation. Adequately supervised. We need the experience of team members and supervisors who in emergency situations have done the drills, they've done the training, and they know exactly how to calmly carry on with the lift-in operation or abort the operation. Competent personnel, well-trained personnel. We have, in lift-in operations subsea, we have a vast variety of personnel, from those on the vessel, those subsea, from many nations possibly, from very different cultures and languages. We need to ensure that we're trained together. And we need certified and maintained equipment. We're working in one of the harshest environments. The equipment requires to be well maintained, and it needs to be certified to do the job which it has been designed to do. So when we look at lift-in, we have three main lift-in categories. And these are routine lifts, non-routine lifts, and engineered lifts. When we look at routine lifts, this is our common characteristics in repetitive lift-in operations, where the lift-in team is well trained and exercised. They have a routine lift plan. An example of this is your compliant launch and recovery system that is taking the diver to the work site and back every day. It's routine. Non-routine are the exact opposite by nature. There is no routine lift-in plan, and due to that, we need to look at a technical review as well as additional risk assessment when we're setting up a lift plan. This is something that we've not done well, and we need to look at it to see if there's additional training required, and we need to look at the risks associated. And then engineered lifts are lifts which are really outside the mandate of the main lift team, and the work starts months before the actual lift plan is even put together. And those are engineered ones where we have engineers offshore who have started designing with specification the actual lift that is going to be done subsea, and then they work together with the vessel and the diving operation team to execute a safe and well-planned lift-in operation. So there's a lot of considerations we need to look at when we are putting together a lift plan. We need to look at the vessel's motion and stability. We need to look at sea states. We need to look at what sea state do we call the job? What sea state can we carry on with the lift-in operation? We have the environmental effects with us as well. We have the weather, we have the wind, which plays a role in this as well. Because we're going subsea, we have surface, mid-water, and seabed currents that can be vastly different as the load is lowered. We have adjacent structures and vessels. We have a very, very busy work site. These have to be considered. Then there's items such as seabed suction, hydrostatic and hydrodynamic loading. Very often this has caught out people with a load that has been designed with a lifting capacity, but they've come unstuck, should we say, with hydrostatic and seabed suction, creating an emergency situation within a lift-in load. And then there's positive and negative buoyancy effects that affect the lift-in operation, as well as diminished subsea visibility. So when we look at lifts with support of diving operations, we have a diver in the water, and this is where we really need to have additional risk assessment. When we look at lifts where all subsea lifts using surface-based lifting equipment, that's the lifting equipment that's based on the vessel, and it's in support of the diving operations subsea, we call these blind lifts. The crane operator has no real idea of what's happening down on the seabed, so he's operating blind. And because of that, we have to have really good procedures. We need to have very clear operational communication. It cannot be open-ended. It needs to be very short and precise to a specific task. We need to have a safe location for the divers during the lifting. We would want the divers completely out of the way. And when we look at lifting, especially at great depth, we have to consider items that could fall overboard. And an item falling overboard has a drift pattern that can have that item landing up many, many meters away from the actual lifting drop zone. So we need to take this into consideration. We need to look after our divers. Our plan needs to be well risk assessed, because sometimes we need the divers in actual fact involved in the final alignment of the equipment that is being lifted or lowered. We need to take awareness of the divers' umbilicals. This is their lifeline, and far too often on a very busy work site where there are many lifts and supporting equipment, ROVs, lowering baskets, tool baskets, the diver's umbilical is a snag item and a risk. Deployment of tool baskets, as said, add a factor to the lift plan. They are lowering tools to support the diver, but if not managed correctly, those tools could in actual fact harm the diver if they're not positioned, located, and stored correctly. So when we look at lifting equipment, I thought it would be interesting to take a manufacturer's look at lifting equipment and what we need to comply with to design a piece of lifting equipment. So I'm just taking as an example a piece of equipment that is used daily and used by many contractors, and that's our launch and recovery systems from surface applied diving. And as you've heard in the previous talks, we have national regulations, standards and codes that we have to adhere to. And if we're operating in South African waters, that is our primary and our requirement and law to adhere to. And as we've heard as well, we have the Occupational and Safety Act, which sits at the top of this, but there are many sectors within it. And if we have a look at a launch and recovery system, it starts to go into these sectors. We have that this piece of equipment is a lifting equipment and therefore has to comply to the lifting equipment regulations. But it also has moving machinery, and so it has to comply to the machinery regulations. There is electrical machinery and therefore has to apply to the electrical regulations. And as we've just heard, there's pressure equipment and we have to comply to the pressure equipment regulation. This we need to all consider, as well as any international regulations if the equipment is going to be used in international waters. And as we've heard in previous talks as well, we have the IMO diving regulations, and we have class certification. And we've heard how these come together. And a point to note there is that very often the local regulations, the international regulations, and the class regulations have certain differing requirements. We need to always make sure that first and foremost, operating in South African waters, we are always compliant to the South African regulations. But if we are to do operations or work in international waters, we need to comply to those. And the class societies, for example, have differing. So if we look at something like load testing, there are different load testing figures required from these societies. We need to ensure that we comply with this in a service towards the operator and our clients. When we design a piece of equipment for lifting operations, we really need to ensure that we take it through an FMECA. It's a word often mentioned in our industry. What is the FMECA? It's failure modes, effects, and criticality analysis. We really need to look at the piece of equipment in the way it is being built, the use of the equipment, and failure modes. So we are supporting life underwater. This is a piece of life support equipment. We need to make sure that there's redundancy and backup within the system. We are required to have emergency power requirements. We cannot just have the system working on one power supplier and the vessel goes black. We need to have standby emergency power for this, dedicated. We need to be able to retrieve the diver safely, and therefore we need to have secondary recovery means of a diver. This could be via a guide wire system, but there needs to be a secondary recovery system, and that includes if, for example, hydraulic winches, you require additional hydraulic power packs, as well as the additional electrical supply. Good communication systems. The communication systems are critical. We're not just talking to the diver and dive control. We have the staff who are manning and handling the launch and recovery system. We have crane operators. We have deck equipment. We have an ROV, and we have an ROV dive control shack. We have all of these, as well as the bridge. On dynamic positioning vessels, we have dynamic positioning systems that we need to interface with. So communication is essential so that the diver in the water is first and foremost looked after, but he has good communication network with everything that is moving around him within this lift. Firefighting systems, we need to have them ready and available on the launch and recovery system for any form of emergency. And we need to have emergency breathing apparatus, not only for the divers in the water, but for the tenders of the system. And that would be the likes of self-contained breathing apparatus. And again, there we're now going to dip into pressure equipment regulation. And then, as mentioned previously, and there will be further talks on this, but a well-run planned maintenance system. We work in harsh environments, and we need to look after this equipment and ensure that it is in good operating condition. The only way that is done is with a really good and well-planned maintenance system with good record keeping. So we look at some of the parts within the system, and we have man-riding winches. This is a system that is lowering a dive to the workplace. It therefore must run on man-riding winches. Some items required in the design of a man-riding winch. It must have an independent power source. It must have main and secondary braking systems. It requires static and dynamic load testing. Remember, we're working offshore. We're working in environments where there are loads that are put on greater than the static load of which you first design the equipment for. When a launch and recovery system goes through a moon pool in the center of the ship, there can be a hangover surge in a splash zone, and this can create additional loads on the equipment. We need to test for those dynamic loads. It's essential that we use man-riding, non-rotating wires. Non-rotating man-riding wires, factor of safety is generally 8:1 on a man-riding wire. Your lifting devices that are not man-riding have much lower factors of safety. And we need regular wire inspection and testing. As said, we're working in an extremely corrosive and harsh environment. We need to look at the wires, we need to regularly test them, we need to look at them against the original manufacturer's main break-in load and look at the deterioration. And we have within the standards a certain percentage of deterioration that we then need to say this wire rope is no longer safe and we need to remove it from service. The dive-in basket. The dive-in basket's very essential that we get the weight correct in the dive-in basket. There are several weights that we need to consider. We have the tar weight, which is the weight of the basket itself. And we have the net weight, which is the maximum load that we are allowed to put inside that basket. This is the divers and any equipment that they might carry with them. And together, the tar weight and the net weight make up the maximum gross weight. It's essential that we know this because of all the testing and the design of the system to ensure that the system can handle the winches, the pulley, the sheaves, the wires, can all handle this maximum gross weight through static and dynamic load testing. The entire launch and recovery system needs to be designed for the structures and the loads on the deck and the sea fastening that will join this piece of equipment to the deck. And then very importantly, there needs to be umbilical guide and release mechanisms. This is a method of ensuring that the diver is always tethered to the basket. This is his first point of return and safety from the working environment back to the basket. But in emergency, that tether system needs to be released by himself in case he has to emergency depart from the basket. And then we have emergency breathing cylinder and emergency breathing apparatus in support of the diver when he comes back to the safe haven to ensure that if he has a problem with his piece of equipment, there is secondary equipment there to support him while he comes back to the surface. So in conclusion, I'd just like to state that for safe use of lifting equipment, we really need to have effective legislation. I think that's why we're here today. We're here to learn about effective legislation. We need well-trained and competent operators, and we need certified and maintained equipment. And we need to be talking to each other. There is a really important exercise to be done as we learn from each other in the way the operators work. The manufacturer manufactures the equipment, and we can follow the legislation to the T, and we can follow the design codes. But if we don't have the practical understanding of the actual work that the operators do, the equipment might comply to the legislation, but it might not be very practical to use subsea. So we want to ensure that the equipment has been designed correctly within the lifting operations that's required. And on that note, I just want to just have another advert of the International Marine Contractors Association, IMCA. IMCA has a wonderful amount of resources, publications, and guidelines pertaining to many aspects of the diving, including offshore lifting operations, detailing some very specific guidelines with respect to parachute lift bags, chain lever hoists, actual lifting operations, setting up lift plans. These guidelines are available, they're there to use. They take many, many years of experience in the industry that they have taken and put it together and compiled. Other people's learnings are there for our benefit so that we can move forward at a much faster and rapid pace into our diving operation. Thank you very much.
Another round of applause for Mike and his efficient use of the mic. May you get well. My granddaughter just got her plaster of Paris out this Monday. So I hope you'll get yours out as well so that we can greet nicely. Well, thank you so much for such informative information, and even for your advert. I think we need to get involved in each other's areas or space, because we are also gazetting a national code of practice for operators of lifting machinery next week. Not this week, we're supposed to gazette it this week, next week. And all our operators, they will be registered with the CETAS and the QCTO in South Africa. So I think you need to get hold of that code of practice once when it's out, so that you are able to align yourself, like I can see that you like to comply. We are also in the process of amending our regs. Remember that we used to be VUP in the past. Now we are PER, but we're amending the PER. The rationale behind amending the PER previously and now is mainly about alignment with the Pressure Equipment Directive of Europe, so that we are relevant. Well, I must thank you so much for your presentation, quite informative, as I've just said. And we will welcome back Jack to come and do the presentation. Thank you so much.
Thank you, sir. Sorry, everyone, you've got me for a second one so close to each other, but I'll try and make it a little bit more interactive, a lot less legislative side. This one is on diving equipment maintenance and what makes it future-proof. I cannot tell you what to do. So the aim of this presentation is just to give you ideas, soundboard, to help you focus. And I'm again adding on to the previous presentation. What I'm going to do is I'm going to take cylinders, so we follow through the process and looking at it. Again, if we take complicated equipment like Mike was talking about, lifting devices and things like that, there's a lot of moving parts, there's a lot of equipment, there's a lot of other things involved. I'm taking cylinders because it's something simple. There's no moving parts, and I'm sure 90% of the attendees here and online think they know everything about cylinder inspection. The physical part of the inspection is not complicated, and people with the right aptitude can be trained. It's the surrounding concepts that's important. And looks like I'm having the same problem again. What makes a good maintenance system? Anyone? What's the most important thing to a good maintenance system? Okay, that's part of it. Most important is management commitment. Without that, and that goes through anything, your quality, your safety, every management system. If you do not have a management commitment, you might as well not do it, because then it's lip service. A lot of the places and a lot of the organizations I've been to, if your CEO walks around the shop floor or the workshop or the work site and he goes, oh, this management audit again, just do the paperwork and get it done. That's going to rub off onto the employees and onto the lower tiers. And they are going to see that the company does not take any management system seriously. So that's where it starts. Management commitment isn't necessarily only funding, resources. It's attitude, and that is the most important. Then we're going documented system, document procedure. If it's not documented, it didn't happen. Competent personnel, and that's what we will get into this onto the maintenance system side as well. Detailed inspection protocols. Have you got what you need? Have you got the right equipment? Have you got the manuals? Have you got adequately training? And then regularly independent audit. It doesn't mean you have to get a company or pay somebody to do. You can do it among each others, audit each other's systems. And unfortunately, both recreational and commercial, people don't like to work together because of fear of competition, but it's important. You need outside eyes. We become blind to things, especially in the industry that I'm working in the QHSE. too long in a certain place, you start living with the problem because you can't fix it now, you defer it, and eventually it just becomes that way. Have other people look at things, and that's the most important thing to it. Discuss, talk about it. Competence is probably the most important thing that there is. Sorry. Wrong way. What do you understand of competence? Now, there's a big IMCA document on it, but what do we understand under competence? Okay? And this is the description from the IMCA document. It's by virtue of their training and experience or combination of both has such practical and theoretical knowledge and actual experience of the plant which has to be examined and tested as will enable him or her to detect defects or wellness, which is the purpose of the examinations. So there's parts to it. We're going on. Who declares competency? Now, it's different to COCs issued by the department. In organization, who's responsible for declaring competence? The organization. You declare them competent to work on your equipment. Who determines the requirements for competence? Is it an organization like IMCA? Is it the regulator? Who does that? Yes, they have input, but the determination is done by the company themselves, or the organization, or the facility. Okay? Is competence for life? So once you've been declared competence, should it be a lifetime thing? No, it shouldn't be. It should be regularly evaluated. I see we've got gentlemen here from the fire department. Now, that's a good example to use. If you've been deemed competent as, say, a compressor operator in one station, you move from one station to another station, are you still competent to do? That different station might have different competence requirements. You don't know the maintenance system. You don't know who to report to. You're still capable of doing it, but you might not be competent. So your requirements to be deemed competent by that station is different to where you're coming from. So think of it in that way. It's not a one-size-fits-all. It has to be reviewed. Every organization has to do something differently. What is required in order to declare somebody competent? There's two facets to that. Under the organization, you need a document requirements and minimum outcomes. What does that person require? What is the minimum outcome that he needs to achieve? Have it documented so that person knows what he aims at and whether he can do it or not. It's not, okay, you look good, okay, today, Monday, you can do it, no, maybe it's Friday, that type of. It has to be documented and properly done. Necessary training and resources. How can that person achieve the competence if he doesn't have access to resources or training? You need to train him on your system and your competence, whether it's internal training or external training. That's what you as an organization will have to determine. Continuous monitoring. As we said, it's not for life. You need to monitor. If there's things where people deviate and we're all not the same, we have lapses in judgment, you have to move away, assess it, and correct and steer the person into the right direction again. Changes in standards, changes in equipment, updates, they have to be made aware, and you have, as an organization, have to provide that to the individuals that you employ and have appointed. Then you have to declare the competence in writing and then appoint them for specific activities. You can't just declare somebody as a blanket declaration. As we talked about, there's a magnitude of equipment on a work site, on a job site. Somebody might start somewhere and work themselves up towards something else. And that's where you need to go. This is your career path and how you go about it and what you can and what you can't do. They know what they can, that they can operate within their scope. You know what you've appointed them, and you know what your capabilities are, whether you can do it in-house or having to outsource or get somebody in. Then we're getting the individual. Important. Do they meet the minimum requirements? Now, a lot of the times, it's minimum requirements are set. In the times of maintenance, you need a technical aptitude to be able to do maintenance. look at that. And that's why we have, not everybody can do everything. There is no sin in it. We all are different. Other people are different in different aspects. People are focusing on other things, and we've all got different skills. Get the right person for the job. So that's your minimum requirement. Does the person meet that? But you have to stipulate that. Have sufficient knowledge. You have an entry level. As you go through the requirements as well, through the training, for your normal commercial diver training, there's a minimum entry requirement into each level that people have to achieve. What is your requirement for that? And then very importantly, your evaluation is based on 3 things. Can the person do that task safely? Can they do it without assistance? And can they achieve the objective set out? There shouldn't be a time frame, unless you're throwing a hand grenade. Then there is kind of a time frame. Other than that, people become more efficient as they do it more and more often. So think about that. When you started, you were slow and you were meticulous. Later on, you start learning the system, you know how to do it, and you get better at it. So that's very important. Person, does he do it safely? Does he do it without assistance? Does he constantly ask for help, or somebody has to help him? Then he's not competent. Or can he achieve the objective? So those 3 aspects, very important. Now we're looking at the MCAS. Now, and again, as I said, we're going to do cylinders, and I picked one of them as an example. So we've got a dive technician competence and training. The level of training required and the level of competence for an individual will depend on the complexity and range of equipment they can work on. So, as we said, aptitude is important. Formal qualifications. So if you look at the document, it tells you, you have to have somebody with a technical aptitude to start off with, or a trade in that field. I'll never be a surgeon because I don't have the aptitude for that. So get people that can work on the equipment. I know we all want to save money and we want to do it most cost effective, but in the long run, it can end up costing you more than what you aim for. Just an example, a graphical representation of how you look at it. You need to start off with your minimum requirement. Does the person have a technical aptitude? Then you need to give him the basic skills, how to deal with different aspects, whether it's regulators, cylinders, hats, that type of thing. The overall view to make sure that you've got the right person for the fit. Then you move on to the equipment-specific training, whether it's a Kirby hat course, whether it's a regulator course, whether it's a OEM course. That is after the fact, once they know how to use hand tools, how to do the different things. So you don't start off with the most expensive course and expect them to know exactly what to do. You build the individual up to where you see him. And that's why, and during that phase, you can evaluate, is he the right fit for the purpose or not? Categories, you all know the categories in the IMCA requirements. You've all seen that. There's 1, 2, 3, and 4. So category 1, the diving life support supervisor duly appointed by the diving contractor. So that's your supervisor. Yes, in some cases, and we talked about it, some of the other presenters talked about it, it's easier to teach somebody with a skill to dive than it is somebody that's capable of diving to teach a specific skill. So is the person capable of doing the job? So as we go through the categories, you'll see it being represented later on. Here's an example of what I did for a test station. So this is a declaration of competence, both on theoretical knowledge and practical knowledge for a cylinder inspector. This is not necessarily even somebody that can sign off that this inspection has been performed. So if you look at that, you've got a theoretical requirements. He's competent or not yet competent. Not yet competent means he has to do that section. You can't declare him competent for anything. You've got your theoretical, you've got your practical. He evaluates you, you give him feedback. It's an interactive process. So he knows, the person knows where they can develop and move on and how they can progress through that. They can build up. You can identify which areas to address. And that through a process like that, the individual themselves, 90% of the time will realize they can't do it. It's not for them. And they will inform you. They will know, if you've got a well-structured program, they will themselves accept that they are not there yet. And that is the easiest person to work with because you've highlighted their own inabilities. and you don't have conflict then, and that will also motivate them to do a lot better. So this is on the competent side. So as we go through the example, we talked about cylinder inspection. So if we look at, this is the IMCA. This is for detail sheet 10.1, seamless gas cylinders being taken underwater. So let's call it our bailout cylinders. So we can see manufacturing in accordance with the recognized international code of standard and fit for purpose, it will be used. We talked about it under the PR side, code of manufacture. So this ties up to the local legislation or regulation without being even attempting to do so. It says it has to be manufactured. You can't just do your own thing. Somebody has to recognize and endorse it. We're looking at our service intervals. We've got an external visual examination, 6 months, by all the levels. Then we've got, if we start looking at our visual examinations internal at 6 months, by level 2 or level 4. And then we've got a thorough internal examination, visual inspection every 2.5 years, by level 3, and then a pressure test 1.5 times, or as stipulated by the manufacturer. Now, if we look at that, or the factory required by the design code or standard. So if we look there, we've got a level 3 or 4, which entails you, according to the IMCA standard, it says you can do it internally. Do you want to take that responsibility on not only the equipment, but do you want to do it internally? So if we go on, I've put the IMCA requirements, and here's the, from SANS 10019 and 1825, the local legislative requirements. So you can see the international requirements is 5 and 2.5 years, and then for, on the diving side, every 6 months, where our local legislation is 2 years visual inspection and 4 years hydrostatic or pressure testing. So there is. But this is, in terms of the South African legislation, is the statutory inspection that you cannot exceed. You can do more frequent inspections. You always fall back to the safest one for your industry. You don't exceed it. You can always reduce it. So what it implies is it just means you can't do the statutory inspection. Now there's a lot of, and this is why I choose this one as well, is a lot of entities, individuals think they can do an inspection. There's a lot of administration, there's a lot of documentation, there's a lot of knowledge to understand. A lot of the persons that I speak to through the assessments and audits that I go to, you ask them is, how do you know the cylinder has passed internally? It looks good. So-and-so told me it's okay. This is not how an inspection works. So if you want to do it, nothing stops you from doing that 6-monthly inspection. Is your people competent? Have you trained them adequately? Have you got the necessary equipment to perform that inspection? You might not issue a statutory inspection certificate, but you're not required, as long as it's being done every 2 and 4 years, as required by the South African law for cylinders being used in the Republic. Maritime side, different issue. We're looking at the IMO standards if it's purely in international waters. So look at that and how you're going to do it. Don't put that risk on you. And we've talked, if there's one thing that we need to go away from this, is risk assessment and deferral of risk. Make sure that you do focus on your core business. There's other entities that does and specializes in different parts of the scope of activities. If we look at this, only approved test stations shall carry out the periodic statutory inspections and testing of pressure receptacles and be done in accordance with 1825. Now, if we look at further periods shall be provided, the dryness or the frequency is given in this table is the maximum interval, as I mentioned. You can do it more frequently. So if people are not complying with the air quality standards and they're pumping some air with their water into their cylinders, they might have to do it more frequently, because you are going to get deterioration and all your equipment in line is going to be affected. So think about that. Now we're looking at, if you look at the IMCA, if we need to look at, if you're going to want to decide to do this, even if you're not doing the statutory inspection, the IMCA requirement says so. If we're looking at our seamless steel cylinders for being taken underwater or the aluminium, it tells you you have to do it in accordance with ISO 18119. Or in South Africa, we've adopted it, so it SANS 18119. So you're looking at, you have to, as we looked earlier, you have to have the cylinder manufacturing certificate. You have the importer's declaration of conformity. You have to have the valve manufacturing certificate. You have to have valve parts diagram and maintenance and spare parts. Have you got, and then the integrated standards. So have you got the latest copies of SANS 347, 10019, 1825, ISO 18119, and then most of the inspections being done, 18119 refers to when valves are fitted or removed or inspected, it has to be refitted in accordance with ISO 13341, and the inspection and maintenance of valve has to be done in ISO 22343. Who that fits valve and inspects valves, because not all test stations do valves. They're not required by law to do that. For the guys that fit their own valves, how many of you have actually got the latest copies of those standards, those ISO standards, on site? So you are doing something that even your own guidance, IMCA guidelines, and you don't have the necessary documentation or the supporting evidence. So you're putting exposure, unnecessary exposure, onto yourself as an organization. Why? Think about that. Look at your core business, focus on your core business. Train your people, do the right thing. Documentation and records. All examination and tests carried out need to be documented in order to demonstrate in future exactly when they were carried out, by whom, and exactly what work was carried out. That is straight from the IMCA. Most of you that follows it, reference it, talks about it. It's even referenced in the Code of Practice. Major testing examinations, salt tests carried at extended intervals, such as annual wire rope inspections, 5-yearly pressure tests. These will not, in most cases, be carried out by witness by third parties or experienced or certified bodies. Regular examinations, testing at regular intervals, 6 months or less, at which may often be carried out by diving or life support supervisors. Is your life support supervisor, is your diving supervisor, are they technically capable of doing that? They might be good at their job, but are they technically minded to be able to do that? External visual inspections, pre-use inspections, they might be fine for that. If they can do the job, you've done your competence assessments, you've appointed them for that, they do have this necessary aptitude to perform those type of inspections. They also need to understand is where are their limitations. When they're out of their depth, they need to report to somebody else, and it needs to be carried on and taken forward from there. Planned maintenance system, whichever system is used. So remember, it doesn't say you have to have the latest, most expensive system. It must be a functional, working system that needs to meet the minimum requirements. And things to think about is inclusion of manufacturer recommendations and manuals where appropriate. So if you've got equipment, do you have the latest maintenance manuals? Do you have the latest instructions? Do you have to have the latest recalls? Do you have to have the latest notices, the updates? How do you record it? How do you share it with everybody in the organization? There's no point in keeping it on the CEO's thumb drive or locked in his office when he's not there. It has to be readily accessible, whether it's electronic, whether it's manual. And the important with documentation is, how do you get rid of your obsolete documents? It doesn't help just dumping things in a file. And I know everybody's got thumb drives, and we're all hoarders by nature. Eventually, somebody picks up an obsolete document or an old document, and they use it. How do you mark it? How do you get rid of it? How do you archive it? Those documents are important for historical purposes and reference purposes and training purposes, but you do need to get rid of your old ones. Compliance with requirements of this document with some types of certifications achieved by means of a preventive maintenance system. Records of planned work to be kept showing each item of maintenance. So you need to record. You go, if you've got a car, for instance, you take your car in for a service. They know you can recall it at the dealer. You can recall, and they can tell you every single part that was taken, swapped out, done on it. They've got a full history on that car, that vehicle, on that piece of equipment. That's what you need to aim for. What did you do? What did you change? What did you fit? What did you measure? What results did you get? What did you do subsequently after you measured the defect? Did you test it again? Did you certify it again? That is a history, because you can not only will that protect you if there's an inquiry, it will also show you a history. And you can say, this equipment is not fit for use in our environment. We might have to start looking for different types of equipment, different brands, different manufacturers. That's the importance of that. And it will help you for budgeting purposes as well. So not only it helps you a good quality system, but it helps you for future to be sustainable. Records of unplanned work, including repairs, traceability. Who did that? Is that person authorized, competent to do that job? Or is it just somebody that you pull in and quickly come and help? Where is the level of authority? Who's doing the job? Who's signing it off? What can they do? What can't they do? Records to be kept logic. Can you retrieve your documents that you keep? Or is it just being filed in a pile somewhere? How quickly can you get it if you need it? Is it chronological? Is it in a system? So everything should be a system approach. Don't think of the here and the now. If you do maintenance on something today, we all know where you put it. It's on our desk. The paperwork, if we do it hydraulically, it's here. Think about what happens if you need to recall that a year from now, 2 years, 3 years, 4 years, 5 years. If you take in terms of the gas test stations, the person that signs off that certificate as the technical signatory is legally accountable for that certificate that he signed for the duration, even if he no longer works at that company that he tested for and he signed it on behalf. As long as that thing is in service, that cylinder is in service that he inspected, he is legally accountable for that. So think of it in that sense. On the conclusion, good timing. We've got management, we've got management commitment, we've got a system, we've got equipment, we've got resources, we need people, we need to train our people, we need documentation, we need details, not just a signature or something that we discuss. Recall, historical data, archiving, so that it can't be damaged, protected. And then we need to review the effectiveness of our system. So it just carries on. If you think about it, here's just a graphical representation again. We've got our overall organization management system as a top entity. Then we've got our management of maintenance and how it flows. Who's authorized to do what part of that? If we carry on, you need to consider 3 aspects, especially in your environment, depending on how you operate, whether you're a school or a contractor. You've got the dive location. What can be done there? You've got pre-dive inspections, post-dive inspections. What level of servicing can be done at the dive site? Do you have the people for that? What type of maintenance can be done? So at your dive site, you want to keep people going and you want to get people out safely. Then we've got a dedicated workshop. Is it your own workshop? Is it an outsourced workshop? What can they do? They're not going to do pre-dive or post-dive inspections. They're going to do service and maintenance. So what equipment goes where? Then you've got third-party vendor. Do you have service level agreements upon them? Are they the agents? Can they get the spares? Have they got competent persons? So that's what you need to consider and look at a proper maintenance system. And then you've all seen this before, the PDCA, Plan, Do, Check, Act. We plan our business. We implement it. We've got our system. We know what we want to do. We implement it. We do it. Then we check. We take historical data. We take information. We see, has it worked? We get feedback. Is it working? If it's not working, we change it and we start the cycle over. Even if it's working, we go through the cycle again through internal audits, review, peer reviews. We look at it and we make it as robust as we can. Do not stop. A system is not static. It is a living system. It has work for you. Your requirements change continuously. Your operations change continuously. Look at it, integrate it, and make it work for you. Thank you very much. That's the end of mine. Thank you, guys.
Ladies and gentlemen, a round of applause once again for Jack and Mike. What wonderful presentation they did for us. And now it's going to be a time for questions and answers, Q&A session. Just hope that the mics are ready. Do you have the mics? Okay. And then We have people that are recording the questions for us. Okay. So let's see with the hands. Firstly, let's start with the questions for, okay, we can just have random question, whether for Mike or for Jack. I've noted yourself, sir.
Good morning, everybody. It's on. Good morning, everybody. It's Bill Chilton from IMCA here, and I've got a question for each of the gentlemen. Mike, on your near to last slide, you mentioned the terms when the picture of the dive basket was up there: tear weight, net weight, and max gross weight. This year, IMCA embarked on a program to update our documents because we were using terms such as safe working load. From some contractors and some diving companies, we got incredible pushback from that. There was a real desire not to change. I'm just wondering, do you know anything about the background to that? I was led to believe it's something to do with the term safe working load that has legal connotations, but yeah, I was just wondering if you knew anything about the background and when these terms came to be common parlance in South Africa.
Thanks. I think it's the terminology, and we've had to do, in our factory, we've had to do a complete audit of all our equipment. We've adopted the new terms and references. It is, as you said, for an international market, we need to ensure that we adhere to that. So I think it's terminology that's developed over the past, and we've wanted to correct it within our organization for international clients. So I think that's where we are.
So from your point of view then, that's the correct terminology and that's the way that IMCA documents should be going forward?
I think so. I think it makes it clearer. So there's no confusion. As you can see, there's often been a confusion on the weights. When you look at the equipment being lifted and loaded, there's the different weights, as well as on a launching system, there's its out-of-water weights and load that it's going to be lifted onto the actual diving platform. So it can get very confusing. I think getting the correct terminology clarifies for all.
Brilliant. Thank you very much. And then, if I may, sir, just a question or more of a comment to Jack. One thing I really want to make clear to people is that IMCA is guidance, and what we say at the start of every single document is if you have national legislation, that takes priority. IMCA is just guidance. Always work to your legislation. Just because we say something, don't do it if your country has laws that are more stringent or even less stringent, but work to your country's legislation.
Is the question for Jack, or is it for, or was just a comment? Okay. No, thank you. Any other take for questions? I think, well, we have another hand. Please let's avoid dialogue.
Thank you, Program Director. Good morning.
Good morning, sir.
My question is more about something perhaps that was not said. It is directed to Jack. Sorry, I'm Sanil Maraj from KwaZulu-Natal, Department of Employment and Labour. I think in your introductory remarks, you said that you may not necessarily agree with everything, and that worried me a little bit. That as our legislation itself, as the department, legislation is not static. It's changing with changing times and technologies, etc. So I wonder if you're willing to share some of the things that perhaps you didn't agree with, that maybe it can, provoke our thinking as the department if it can enhance our work as well. Thank you.
Thank you very much for that question. And I would like to clarify, because remember, we are having a very short time to go through it, so I had to go through it very quickly because it's a very, very inclusive legislation. So with the standards, it might not have been written specifically for the diving industry. And as I mentioned, it encompasses everything, all the pressure equipment, all the cylinders being used by the diving and the industrial side. So it's not, what I meant is, it's not my viewpoint. It is what's written on paper. So some of the things you might not 100% agree, but it is the best way to look after the industry. And we can only move forward. In the past, it was, if you look at SANS 10019, it was all inclusive. Everything was mixed. And whoever's got the most skin in the game had the biggest voice through the committees and through everything. We've managed through Edition 9 to have, for scuba and SCBA, we've got our own annex now that specifically deals with scuba and SCBA, which can be further developed with input from the industry and going forward. So there's nothing wrong with it. It's not unsafe, but we can, like was said, is lining up more with international to make it easier that we don't do our own things, to get it easier to interchange between organizations and international communities. So it's perfectly fine for what we're doing, but we need to get, it mustn't stop. Exactly what you said. It never should stop, and everybody should participate when there's commenting phases. And that's why I said my email is there. When the standards go out for comment, there is a mailing list that I send it all out for people to participate and having comments, that we can have effective discussion for the next review. A review, sometimes there has to be corrections. 10019 should be out. They had to, with legislative changes, they had to update it, so there might be one recently coming out. But roughly every 5 years, there's a major review, and these things can be thrashed out through the committees, submitted, and we can improve on it. We don't want to go back. So if that answers your question.
Well, thank you. Are you okay with that response? Sure. Can we have the last now question? Because we're going to close this session. And then we will then ask Mike and Jack to come to the front. And Warren, we have the gifts ready. Can Mike and do you have a question, sir? You might what? You may have the you may have the mic.
Thank you for that opportunity. My question is directed to you. I just wanted to inquire: is there a official database with all cylinders, especially diving cylinders for scuba, and compressors that's coming into the country, that's imported, that's brought into our borders? Is there a database for those cylinders, and where is, if there is one, and if it is regulated, where can it be found?
Thank you very much for that question. That's a very good question, and the short answer, no. As we said, is the owners rest with the importer, and then subsequently the user to have the documentation, because there is no importation system. There's no permit system. That at the end where I showed you, that is what we've tried subsequently with people. It's a voluntary system. It's online. You can see what is available in the country. It is by no means complete, because it is what people present, and we added on. We'll review compliance based on that. We've tried the importers to get them involved and to say, submit as you bring it in, let's move forward. It's very difficult going back. We can only look forward and try and make it better and getting as much as we can. But legislative-wise, there is no such system in place.
Maybe in addition, it doesn't mean that if there is no database, we can't do anything. We are not helpless. We are regulators. We have registers and records for all the importers that are supposed to, not actually the names of importers, but the equipment that they import has to be certified and all that. So if you pick up an equipment and you look at the stamps and all that, it can be traced. We're working very close with the South African Compressed Gas Association. We're working very close with, for LPG gas, we're working with the LPG gas. We have what we call the South African SAQCC, where all gas organization associations are together to certify installers, authorized persons, and all that. So there is information. And also even the legislation compels users to be able to keep records. So if there's an incident, we are able to can do that. I don't know about, in South Africa, do you have people that are working with you, IMCA? Is it SAMSA? Only SAMSA? I mean, about equipment and all that.
Not specifically.
Yeah, okay. Yeah, but maybe this calls for collaboration, coordination, and all that, but we'll talk about that later on because it's not that things are not regulated. South Africa is well regulated. South Africa is well regulated. There are legislation, there are standards. Even if we have to come up with a code of practice, national code of practice, in the past I think we have more than 10 code of practices in the Department of Labor that we've produced. So there is some regulation. If you have problems, you come to the DOL, you go to the DOT, the South African DOT, but we also mention in some documents the American DOT, and we also work together with the UN regulatory models. So there is some regulations in that regard. In the absence of any itch or any question or raising of hand, I'll ask Mike to come to the front, and I'll also ask David to come to the front. This is just a time for us to acknowledge. You come on the stage. Down there. Okay, they say you need to go down. Maybe I should hand out the. Maybe I should hand out the. Thank you so much, Jack. Thank you for the presentation. Well done. And may you enjoy it. Thank you so much. Thank you so much. Well, ladies and gentlemen, we have done the first session for the day. Please come back for the next session. It will be driven by a wonderful, beautiful lady, interesting lady. Please come back. This is the closure of the first session. Thank you so much.
Can we start coming in, please? Can we start coming in? Can we settle down, please? I can see you are enjoying this place. So you want to be here until 5 p.m. I don't mind. According to the program, our next speaker is Mr. Peter Truter. He's the manager of the Research Diving Unit at the University of Cape Town. He is a Class 3 instructor with 22 years of diving experience in both the scientific and commercial diver training industries. Mr. Truter holds a BSc degree from Stellenbosch University with majors in animal physiology, genetics, and aquaculture. In the late 1990s, he was one of the pioneers in the abalone mariculture industry. Mr. Truter sits on the Diver Technical Committee, and he is also a member of the SABS and ISO Committee Working Group, currently compiling the ISO TC 228 WG1 document. Mr. Truter, he will be presenting on the topic of underwater scientific diving tools and techniques. Let's welcome him with a round of applause, please.
Thank you very much, Yabu. Yes, so my talk is supposed to be about scientific diving techniques and tools, which is a bit of a low one in this conference, because the whole conference was about health and safety and things like that. And now we're speaking about something that I see the commercial industry as a whole is trying to get rid of. But hopefully through this presentation, I can show the audience that there's a huge need for scientific divers, and specifically the technique and equipment that they do use. And who falls under this category, because it's quite a wide category as well. So let's start at the beginning, and basically what is scientific diving? And scientific diving is a diverse field that covers many aspects of commercial diving, and yes, it is commercial diving because we are working underwater and we're getting paid for it, indirectly or directly. So basically, it's commercial divers diving for data collection. So we collect data. We do also sample collection, and hopefully I don't have to go in the difference between data and samples. And then it goes further. It goes installation, servicing, cleaning of scientific instrumentation, which is also important because there's a huge difference between scientific instrumentation and commercial instrumentation. If you just take something, there's pictures that I'll show later, wave rider buoys. It's an instrument, it's a scientific instrument, but a buoy is a buoy. And the commercial guys, when they clean the wave rider buoys, most of the time they break the stuff because they don't realize it's a scientific instrument and everything that's involved inside that instrument. Then we've got videography, and we've got guys doing it for educational support. And on that side, that's your aquarium guys, your researchers collecting samples for education. Yeah. Next one. Yeah. So the people that use these skills techniques are, everybody thinks of only scientists. So that's an easy field. In this room, there's a lot of scientists here from a variety of backgrounds. We've got a lot of our government employees, that's scientists. The one that most people know about is from the Department of Forestry, Fisheries, and the Environment, if I get it right. I just call them sea fisheries. Then we've got, from research institutions, you've got the NRF, you've got the universities. There's a lot of private companies doing research these days. Then we've got engineers. These engineers are mainly constructing dams, pipelines inshore, but they do use commercial scientific divers to collect the data, to install instruments to collect the data. They take samples, sediment samples. In especially Cape Town, desalination plants is a big thing. So it's engineers developing it, but the information that they use comes from the scientific divers. Then our favorite people, the police, and I've just put the police here, but under them, we've got all the emergency services. So that's EMS and fire. So I don't know if we've got to go further into that, but they play a big role, and from their side, they use the same techniques as traditionally the scientific divers, because for forensics and sample collection and data collection. Then we've got our educators, and that's mainly your university type educators, but nowadays it goes further. You've heard of public scientists or yeah, it's one of those things. The normal public is trying to get into science, but we won't go into that. You've got your videographers, that's more your film and media people. And then you've got your aquarists. So aquarists falls into this because they also collect samples. You know the Two Oceans Aquarium, you see the fish here. They've got a huge role to play in the marine environment and bringing the marine environment to the public. So they play a huge role in education as well. And then they all linked in research. There. So, big question. What is the difference between a commercial diver and a scientific diver? Or somebody that uses, or the people that I described previously? So the one that I didn't put on here, that's actually probably the most important one. And that is that none of these divers are actually employed for that job. You will see, our police, they aren't employed as divers. They are employed as police officers. Same with fire, same with rescue. Our scientists, we don't have in South Africa really a scientific diver. We've got scientists that then do diving. Same with our I call them the wreck people, our archaeologists. They are archaeologists. And then we've got land archaeologists and marine archaeologists. Same story. It's an archaeologist, wants to work underwater. Okay, how do I stay alive doing my job underwater? I need a commercial qualification. Okay, so they don't get paid as a diver. Diving is their secondary job. All of them have got a primary job, which is very important. Commercial divers, you are employed as a diver. It's as simple as that. That's your job, most of the time. But they do a lot of other work as well. So they, in our mindset anyway, I see you shaking your head, their main job is underwater, but they play a surface role. Otherwise, you could have employed a surface person. In the old days, before my time, so I'm the third generation manager of our unit. My predecessor was there for 40 years. The guy before him, Alex Fricker and Peter Zoutendijk, they were there, I think, 20 years before him. I've been there 20 years, just to give you a frame of reference. When they started, the people that went into the commercial field were basically tired of working on land, and they went into the diving. Just to give you an idea of those things work. But anyway, I've got a tendency to sidetrack myself. If we carry on, he must be self-reliant. The reason we put in I put that in there, because these guys use scuba most of the time, and now we've got air scuba and commercial scuba in our regulations. I'm talking here about air scuba. And traditionally, it means that you don't have the backups that you do have with surf supply, which means these guys need to be better trained to look after themselves because they know there isn't endless air supplies, lines going everywhere, and all the other backups. All right. So that's why I put self-reliant. For this type of work, they must appreciate the effort that it requires to collect the data, and they must do the best possible job to collect that data set at that time. Because you've only got one time. It's most of the time the jobs that we do, especially on data collection, sample collection, you can't come back. The marine environment just, I mean, you guys know, that is what it is. It's different than your offshore platforms. If you do it tomorrow or today, who cares? The platform is not going anywhere. Again, coming back to our favorite guys, the police, that body is there today, tomorrow it sits in Australia, floated away. So that it's a maximum effort, get it done. Then understand that scientific instruments are very sensitive and fragile. I did work at the CSR for about 5 years. We lost a lot of instruments because the clients didn't want to pay for scientific divers to do the job. They wanted to use local commercial divers. Every time the commercial divers serviced the instruments, it either got lost or got broken. They just don't have the skills required for that specific job. And then last one is they need to know their limits. In that case, that gets complicated. It's got to do with team size, team dynamics, who can do what. The other day, me and my colleague had a conversation, and excuse my French, but we are a little bit blunt when it comes to these things. And I asked her, do you need a hand or do you need a brain? And I was told that's not a nice way to put it. What I meant with that was, do you need somebody to just sit, hold on to things? Or do you need somebody that knows, for this specific jobs, it had to do with organisms and identifying organisms underwater. So that's what I mean. Do you need a brain? In other words, a person that understands all those fancy things that they look at. Me, myself, some of the jobs, I'm just the hands. Other jobs, I'm more the brain. All right, so that's what I mean by know your limitations. All right, so all of that said, let's look at some of the pictures and how we construct our diving environment. And that falls very much into the same with our commercial guys. If we don't have to dive, we don't want to dive. So if we can, we wait for low tide, let the water be out of the equation. And this is a project that is still going on at De Beers. Well, it used to be De Beers in Ludwig, where we do surface quadrats. That is all underwater at spring high. So we wait for spring low. There's only 2 times in a year when we can do this job because it's the lowest low tide, and that's what we do. They've been going to that same site for about 20 odd years. There's bolts drilled into the rocks. They put that quadrat on the right-hand side, and they do their counting of the gogas that grows there. I call it gogas, but yes, the marine organisms. Okay, the next thing is, again, if we don't have to dive, we don't try not to. We use acoustic releases. So it's very nice instrument. You can use it to deploy tons and tons of instruments. You press a button and it comes to the surface. Divers aren't at risk at all. This comes from, we installed these things at the FA platform a couple of years ago for current meters that we deployed there for them. And you see on the left-hand side, that's an acoustic release, and it was attached to one of those buoys. And the instrument on the bottom of the buoy is basically an acoustic current Doppler profiler. It's an ADCP. It measures waves. And in this case, this one only measured currents. That sat at 200 meters. Obviously, we don't dive to those depths. So that was the best option for that job. And there's a lot of those type of tools available, especially in the certificate environment. And the offshore guys also use those equipments. Those pingers that the guys were talking about the other day, those personal pingers, we've been using them for years. It's not new. CSI had those things for like 20, 30 years. It's old stuff. They even developed the stuff. So that buoy on the right-hand side, to give the guys an idea, so this was at the FA platform. The anchor for that system was about 2 tons. that we had down there. And all of that had to be lowered to the seafloor, and then the rope released, because you can't just drop it overboard. You destroy the instruments that's inside there. When we do have to dive, so that is the same instrument, just a smaller version, at the seafloor or on the seafloor. And we use scuba divers for that. It's on a frame. Every 2 months we go back, find the thing, change it out, and off we go. Very simple. To install that, we used water jets. So we jetted those pipes in. Simple. So yes, there's a lot of guys that says scientific divers don't work. We do water jetting. So yes, we do it on smaller scale. We don't do these huge pylons and stuff. Where do you think water jetting came from? Scientists. Then other methods, tubes to collect sediment samples. Very simple. Diver go down, grab the tubes. Depends on what you want to measure. It's not as simple as that. Sometimes they want the different layers in the sediment. Then you can't just stick it in a jar. So again, you can't use a commercial guy that don't understand the science behind it. Sometimes you can, sometimes you can't. Okay. You can do this with a machine. You do get what they call multi-corers. We do use those, but then if you don't know what the bottom profile looks like, you hit rock. So a lot of times, for the bigger projects, there was a huge project in Table Bay 4 years ago. And for one of the issues in the media at the moment is the outfall platforms, outfall pipelines around Cape Town. For years, we've been taking sediment samples using core samplers, and areas where the machine doesn't work, we send a diver down. We used to do this when I started to 50 meters off Robben Island on scuba, 1 cylinder. We did tie the guy to a rope, obviously, but yes. All right, just a short video. This is thanks to one of the companies that we work with. We'll see, the video is a bit big, so it jumps and go crazy a bit. But it's basically using an airlift to take a certain volume of sand, and then the sediment gets sieved, and they look at the organisms that lives in the sand, and the impact that whatever structure was close to this, the impact that it's got on the marine environment living in the sand. So again, very similar to commercial guys. They use LP compressors, they use ball valves, hose pipes, airlifts, all done on scuba. One of the reasons we don't use surface supplies for this is because of the number of samples that needs to be collected. These dives can be at 30 meters. It takes about 5 minutes, 6 minutes. Yeah, it's relatively short dives that we do, so it's a lot of bounce dives. You don't want to set up a surface supply system every time you do a 7-minute dive. It's going to take you the whole day. It's not financially feasible for the client, especially if you take into consideration your risk assessment and everything evolved around that. Again, you can't use commercial divers for this. They don't understand the science behind it. They don't understand the certain volume of sand needs to be collected and how you collect it. Okay, so just a quick video about that. Okay, next one, quadrats. For small jobs, use a quadrat, very simple, go down, and depends on what they want to do. Most of the time, they just count in the blocks. Again, similar technique what the police are using, they're just using bigger quadrats, cargo nets, whatever. Same technique. Next. Then, this picture is courtesy of the police, just to show you again. Metal detectors, use a lot of that. Underwater and above water. Grid line search, guided grid searches, and then evidence collection. Okay, just to give you an idea of how the police operates. And one thing that we didn't talk about for them also, and for us, risk assessment. Contaminated water, not necessarily on scuba, dry suits, full face masks. There are options, and we do use those options. Even as scientific divers, we do sometimes use full face masks. Sometimes you have to communicate to the surface, we use comms. Random sample collection, again on the right-hand side, that was in Namibia. Very shallow, maximum depth there was 3 meters. And the 2 people in the front, they were doing quadrat stuff. The 2 guys in the back did crayfish collection. So they do what they call a catched effort. So they've got to see how many crayfish can they catch randomly within half an hour. And according to that, you work out stocking densities. You can't do that on surface supply. It's stupid. The science just doesn't work. And then on the left-hand side, mussel rafts in Saldanha Bay, looking at the mussels, doing biological sampling there, and taking notes of what grows where and that type of stuff. Very simple. But again, go and do that with surface supply, you will get tangled up. All right. This video is just a quick one. Transect lines. There's different ways to do transect lines. One of the ways is using a weighted chain. And this one was just counting the crayfish, 1 meter on either side of the chain in 5 meter increments, and you write that down. Again, for this, years ago, when fisheries were still very active, they used to do abalone counts on a yearly basis, 60-meter lines, worked out stocking densities. When I did it the first time many, many years ago, there were so many abalone that you couldn't count them all. You counted a meter on either line. Then the commercial guys started saying, yeah, but the scientists are underestimating the stocks and things like that. They want to do their own counts. They don't understand what a meter is. Everybody's arms are different lengths. So they came up with huge numbers, because when they see an abalone, they count it. They don't understand there's a scientific principle behind these things. Okay. And then other methods, just taking pictures, using tubes to collect at different water depths, writing stuff down. So just to give you an idea. Cleaning and inspecting of scientific instruments. Wave rider buoys. This is a wave rider buoy off Mossel Bay. Each of our ports have got wave rider buoys. They need to be maintained every 3 months. I don't think there's anybody from the CSIR here. No. So they maintain these buoys for the harbors, for TP and Transnet National Ports Authorities. And one of the guys went to Datawell last year and explained to them how we manage, or how they manage it and how we manage it, how it gets deployed and all that. Those guys couldn't believe the environment that these buoys operate in South Africa. Their bungees, I don't have a, so these things are buoy on the surface, bungee cord goes down, and then the bungee cord changed to a rope. Their bungee cords do not have safety lines on. They change their bungee cords once a year. These bungee cords, sometimes we have to change them once every month because of the growth we get here. They don't even paint their buoys. They just don't have the growth that we've got here. And our growth is weird. Our growth likes to cut the bungees. So, yes, it's difficult to bring European standards into our diving environment. We've got a weird diving environment here. When I was in the mariculture industry years ago, many years ago, fish cages and all of that was a big thing. The salmon cages, the Norwegian salmon cages, still a big thing. Those guys designing, building those cages would guarantee them everywhere around the world, except in South Africa. They say they can't guarantee those cages will last in South Africa because of our marine environment. Okay, so yes, we clean them, we inspect them, same as the commercial guys, same story. We just do it a little bit different. Next one. Okay, and just to thank a couple of guys with the pictures and stuff, the CSR, Anchor Environmental Services, and the police guys. And that's that.
Thank you, Peter, for saving even time for us. Our next speaker, it's Mr. Barry Bielefeld. He's an electronic engineering. He started in the avionics industry, 1981. Joined De Beers in 1987 in the ROV section, and he started Marine Solutions in 1999. He will be giving us a presentation on the remote marine inspections, how effective and efficient. Barry, this is your time. Thank you. Apologies to Barry. There's one of our colleagues who has lost a wallet. Did anyone maybe find the wallet somewhere lying around? Okay, doesn't seem like. Thank you.
You can keep the cash, they just want the cards. Morning. I'm Barry Bielefeld, as mentioned, and I'm going to talk a little about ROVs and how they've come about in the last few years to make it much more effective, efficient, and safer all round. Okay, so I'm going to just start with giving a little bit of background, and then I'll get into the ROVs. Right, so a bit about Marine Solutions. As mentioned, we started in 1999. Okay, we're based in Cape Town, and we started off as a small company. Originally had one little Falcon ROV or a high bull before then, and it was always about ROVs for us. And everything we do is about ROVs. We operate them, we sell them, we even have a training facility as well. So we've gone from one little ROV down to 15 ROVs at this stage. Okay, and they range from very small ROVs. If you go look, we have a stand down there. There is, you can see the tiny little ones, which are quite handy. And then we have going right up to the big ones that can go down to about 2,000 meters and do some serious inspections and work. Okay. Right, let's get into the effectiveness and the efficient surveying and techniques. So if we look at ROVs, I take it everybody has a vague idea of what ROVs are. Okay, but I've just broken it up a little bit. There's different classes that you get ROVs. And they start from the very small observation class, which could be something literally about this size. And the weight will be somewhere between 5 and 90 kilograms. It's got a camera, it's got a couple of thrusters so it can move around. And that's just sort of class 1 observation. And then from there, we start looking at payloads. And payloads could be for numerous things. It can be for extra sensors, extra cameras, little bits of tooling, and that goes to class 2. And that normally runs from about 90 kilograms up to about 1,000 kilograms. And that's still called an observation class ROV. Class 3 are the big work class ROVs that you look at, and they normally go from about 1,000 to way over 7,000 kilograms. And those can have, it can be electric, it can be hydraulic, and they can do serious tool work or serious inspections. And very efficient and very effective, and I'll get into some of those techniques a little bit later. Class 4 is towed and bottom crawling. So the towed is quite interesting because those are normally for survey purposes. And the bottom crawling, the one that most people know about, will either be the cable lane or the De Beers crawlers. Those are massive for mining. And then the last is the AUVs, okay, autonomous vehicles. So that means that vehicle, you can program it. It can be with a cable or without a tether. And you can put it in the water, you can send it off for a couple of days, it's battery operated, and it will do your whole survey for you, and when it's finished, it'll pop back up to the surface, contact the boat, and the boat will go and pick it up. That's the theory anyway. Sometimes it does go wrong. Okay. This is a little slide that we've got of an observation class ROV, and it looks like it's massive. That little ROV is in actual fact this size. And it just shows what you can do. If you look at all of those sensors and bits of tooling on it, you can see that literally you can do almost anything that your mind can imagine with an ROV. I think the limiting factor is the person, the human interface, is what you can think. Because that little ROV is so tiny, but yet that company has broken it out to doing all of those things. So it's not going to be able to work in 3 knots of current or even in a knot of current, but it is going to be able to do the functions in the harbor, it's going to be able to survey, it's going to be able to assist with all sorts of applications in terms of survey and also in terms of tasking, to find things. I'm not going to go through all and each one of those, but as you can see, there's manipulators, there's CT gauges, there's a whole list of things. Okay. Okay. To give you an idea on a bit of scientific use of ROVs, way back in about 2005, we in South Africa had the coelacanths, and what used to happen is there would be a German submarine called the Jaeger. De Beers would bring it out, and once De Beers were finished with their uses of it, they used to donate it to the scientific community, and they would use it to go down to Sodwana, and they would go look for the coelacanths, and they would do experiments on that. So with the little ROV, we decided that we would look at seeing if we could use that to study the coelacanths. And the professor at the time, he was quite adamant that the ROV would scare the coelacanths away. So Dr. Kerry Sink, she was very young at the time, and she decided that she would like an opportunity. So we put the ROV, the team together. She brought the scientists, and Neil Scott Williams supplied the boat. And we decided we'd just go prove the fact or not prove the fact. So we had some cameras on it because we needed to do surveying. And we put it down, and on our first try dive, they're close to Jessa Canyon at about 120 meters, nowhere near where the coelacanths were supposed to be, we bumped into a coelacanth on the very first dive. On that trip, 11 different coelacanths were identified, which was fantastic. Kerry's even got a frame, a single frame grab, which is what makes these ROVs and surveying so good, of 5 different coelacanths in one frame grab. That was never photographed ever before. 3 of them in a vertical position, 2 of them horizontal, and all of their dorsal fins were flat, which showed that they were not worried about it at all. So she did an article on that, submitted it to SIAB, the South African Institute of Aquatic Biodiversity, and guess what? In 2010, they purchased their own CI Falcon, and they've been busy with that ever since. They set up a unit for it, and they've done amazing scientific research using the Falcon. They had a 4K camera on it, so the technology had come quite a long time since the old days with the high bulls and the 720 lines. So they had a 4K camera, and we were able to store the data on a hard card in the camera itself and just run the normal TV lines up, which worked perfectly for them, and you can control when to tape. And then as late as last year, they decided they'd done quite a bit up to 300 meters, and they purchased a deep CI Falcon, 1,000-meter rated, full fiber optic with all the bells and whistles on it. It is fantastic, and they've got a boat kitted out for it, and they are going all over with Ryan Palmer. You guys might know Ryan. So he's their main pilot, and they are doing a lot of surveying and a lot of scientific research with those vehicles. Okay. Does everybody know what the coelacanth is? Okay, so it's a fish. It can be quite big, meter and a half, and the living, or not the living, the fossils, it fossils back to about 450 million years to about 410 million years. That's when the first fossils were found of those, okay? And the interesting thing about it is they're still around, and they're around on the Indian Ocean, Sudwana, and all the way up to Reunion, all of those places. They've even been found as low as, on our east coast, 60 meters. That's a coelacanth over there, and this is obviously a frame grab from the 300-meter ROV. That's part of the team, and that over there is Ryan Palmer. Okay. So for the guys that don't know what a coelacanth is, that's a coelacanth. Two of them, that matter. Okay. And just a very short clip, because this is from the ROV. And if anybody would like to venture a guess on the length of that, what would you say that is? Any ideas? Okay, so they look a little squat there, but one of the things that I want to show you, so those lasers there, that's from the ROV. Those lasers are set at 10 centimeters, okay? And in water, it doesn't change. That's one of the advancements that we've had with technology and ROVs. So that's 10 centimeters. So if you look at that, it was 10 centimeters, the fish was that. That would make those fish somewhere around about 1.2 to 1.5 meters long. And that's the great thing about the cameras and the technology and the lasers that you can use now. Let me just go back one. Sorry. Okay. Right, carrying on. For our purposes, search and recovery. We talk about search, surveying. So in South Africa, we're not quite there, but in America, every single sheriff's department has got a mini ROV. Every single customs department has got a mini ROV. They are used to survey ships' hulls to see if there's contraband coming out, to do a survey to find missing body or cars that have gone through the ice. It's just a tool. Every single person uses it, and it's just standard stuff. As you can see, that something goes down, you can just pick it up. It's quite portable nowadays. Just put it in. Even the Falcon systems, they sit at about 300 to 400 kilos. If you take all the spares on that, you can still put it on a plane and fly it somewhere. And that's a lot more quick and effective than setting up a whole team. I mean, there's a place for the team, but if it's something emergency, if you need to get down to somewhere, find somebody that might still be alive, you want to get that survey done as soon as possible to see what you can find or recover. Okay. So we also have some fun in the industry. I just thought I'd put this in here. So ROVs aren't always that serious. So this is Free Willy. You remember the movie Free Willy? Well, the main big orca was flown around using a CI Falcon strapped to it. And that's not the first time. We've done numerous movies with these vehicles driving the actual sharks or the orcas, or even a Bollywood actress in the mouth of a shark. Right, let's have a look at a bit of tooling. So when ROVs first started, it was quite basic, and they had very small manipulators. So manipulators is for tooling, but it's also part of the surveying and the approach to surveying. So if you look at the picture over there, that's just a very simple one-function manipulator. You can pick up something, and that's about it. Okay, then it would change, and you would possibly be able to turn it. That would be a two-function manipulator. It went on to that manipulator there, and that could be a 4 or 5-function manipulator. So technology has come on so far that you would hold something, and whatever you did with your hand, the manipulator would do. So these are quite small. That one over there is only about that size. This one over here is fairly much the size of your arm. Or if you look at that, that is actually a Conan, a shilling Conan manipulator. And that's a big manipulator. It stands about this height just in terms of the actual reach like that. What makes that special is where every time you see one of these, there is actually a PC104 board in there. So it's a full computer board, and that manipulator has feedback on it. So if you wanted to pick up a plate or something, doing a survey on a rack, you could actually, whatever pressure you are putting on there, you would get that feedback back into the manipulator, and you would be able to feel it. So the dexterity of that is amazing. And that would be sort of a 7 or 9 function. So anything you could do. And then programming, you would program it to store itself. So you don't need to store it in front of the RV. You just hit a button, and it will go into the right position, come in. And you would use that to put cameras. You would mount cameras on it over there. You would mount lights on it. So when you're doing surveys and scientific approaches, you can pick things up with that. A lot of the big work class ROVs all have this. The class 2 have these, and class 1 has that. Okay, sensors. Now they've come a long way. Like we said, in the old days, we would have a camera, 570, 720 lines. It would be good for just seeing things. You couldn't really see much with it, and it would be a tiny little highball or something. And then the sonar came out. So for those that don't know sonar, it's literally an underwater radar, okay? And that would be a Tritech Sea King. And the picture you would get is that. You can see an aeroplane over there. It would do a 360 sweep. That over there would be some structure, so you can see where the walls are. You can go into mines. You could survey properly with this. One of the big factors of these, and even the predecessor to this, which didn't have the chirp technology, so it wasn't as good as this. De Beers, when De Beers was when they were operating their drill heads, you know, the big 100-ton drill heads with the pipe to the top, occasionally they would lose one. And then it would take them 2 days to recover this. What we found is that with a little ROV, like a little Falcon, we would have one of those on. We would be able to back off 30 meters from where the drill head is. The ship would drop the string down with a recovery tool, and we would be able to, on a survey purpose, we would be able to align the tool above the drill string, and they would be able to drop it in. So what took 2 days before, just with that, 45 minutes. 45 minutes, bringing it out, dropping it in, like a bit of a ease out, the tap, dropping it, turning it in, and picking it up. Now, in terms of cost, that's approximately 10 million rand back then. Okay, so that's from that. Since then, things have changed a bit more. Now they have multi-beam sonars. Now, multi-beam sonars, in terms of surveying and effectiveness, is huge. That little picture there, and this is not, these are pictures, so the real life is even more clear. But that's a little shark over there. You can see the shark there. These can be used to survey for fish, for equipment. It can pick up bodies. It can pick up people swimming. It can pick up almost anything. So they're not a 360 like this. It would be a sector, and it will build up an impression of that. Okay, so you could then, if you've got a structure, you could build the whole structure up just on that, and you will be able to see very clearly what you're looking at or what you're busy surveying. So what we found, if we chat about the effectiveness, there was I think just before COVID, there was a job for Subsea 7 somewhere in Nigeria. Divers, they had to survey a place where we were laying concrete mats, and the visibility was so bad that the project almost never started. The supervisor at the time said to them, "We think we can assist. We have one of these on the ROV, and we think that we will be able to line stuff up with that." We did that, we put it on, we looked at it. For the next 2 to 3 months, they weren't interested in us, they were interested in the multi-beam. The multi-beam, because of its ability to see exactly and its accurateness, that project carried on. There wasn't one person that got in the water because the visibility was so bad, but it never stopped the job. The job actually carried on because of the effectiveness and the efficiency of that multi-beam sonar. It was very good. They were very happy with it. And a lot of what we've done now is a lot of the little ROVs, we have a system like that on the little ROV itself, because when we come to diver support, it makes a big difference as well. Okay. If we look at slightly bigger systems, this is a system now that's actually busy as we speak. Mike might recognize this. So it's a project that's been done in conjunction with Mike and OSC Marine. And this year is a very, very effective camera system. It's a 4K video stream, 3D modeling. So what that will do is it will allow you to go down, look at links in a pipe, and it will model it. And instead of going in there with a caliper and trying to measure to see what the wear of that is, the software itself will actually put it together and tell you if there's any problem. You will be able to measure it, and you will be able to determine. Think how much time that saves. Okay, so that's on there. That's the camera system there. There's about 20,000 lumens of light. You can see the lights over there. And then with these things, with the ROVs, you can do almost anything. Like I said, it's your mind that holds off on it. Okay, so if you look at that, that over there is a flapper brush system, because you want to do an inspection on a member, or on a chain or something. So we would take that, and that would rotate. There's a hydraulic coupling over there with the motor, and that would rotate, and it would clean off that whatever you're wanting to do, and then your camera would be able to get your good picture there, and you'd be able to do your measurements. Just like that. Nothing else needed, except lots of people on the top to post-process. Okay, so, and then there's the manipulators we're talking about, but these are 5 or 7 function manipulators, and then lights, brush, and that over there would be the cameras, lights, and cameras, the ROV's cameras and lights as well. So that system, as you look at it there, is a big system, stands about this size. It's in a garage, it gets lowered down to whatever depth you're going to work at, and what that does is it makes it nice and stable, so it allows you to operate and do your surveys or whatever other work you want to do in times where there are better currents. But when I say currents, we are talking to about 1.5 knots. Once you go over 1.5 knots, everything changes. You need massive, massive hydraulic vehicles to be able to work in currents more than 1.5 knots. Okay, so if we look at the software that goes with this, so we looked at the camera systems. This is a fairly, I won't say old, but it's not the latest. This has been around for a while. So one of the inspections that a lot of the companies need, the oil companies need inspections. They need the pipeline inspection. So if you go back to, let me just go back to the ROV there. So if you look there, we have a manipulator. So when you're doing an effective pipeline inspection, you would have 2 hydraulic arms that would go down on either side of the pipe. You would have a light and a camera so that you could survey the size and the sides of that pipe, and you would have another camera that would look at the top. You would then also have 2 sonars and those would be profiling sonars, and that would then scan the pipe to see if there was any damage in the pipe. So you're doing 3 visuals, and you got the sonar on 2 sides looking at that. So what this survey used to do is it would put your main camera, your 2 side cameras, and these of here would be from the profiling sonars. So you would have one ROV flying, and then you would have your annotations over there from your co-pilot. You'd have one ROV flying, and all of your data would be put into one software package, and you would have one report that does that, which has come such a long way. In the old days, you'd be running boxes and boxes of tapes for each camera before this came along, and you would have to, if there was a problem with your pipe, you would have to go back, you would have to see where it is, then you'd have to go find the other tapes that match that, and you'd have to link it all together. So these are enhancements in the software that just makes it a lot more user effective. This is a very new workstation. It's a digital edge, and it's also cutting edge in terms of scientific, in terms of efficiency. So what this does is instead of having a massive bunch of monitors and that, it's one workstation and everything. So you've got this, which could be your main camera. You've got this, which is your sonar. You've got your keyboard. And over there, you've got about 2 or 3 options of what you want to play. And each of those will close up, and you can walk away with the briefcase about that size, by that size, by about that size. And it can take 3 or 4 4K feeds, plus sonar, and it's one package, and it will store it as well. These are fairly new. SIAB has got one of these with their new system, and it's an absolute dream. It just makes it so much more effective and efficient. Right. Speaking about scientific explorations and efficiency, in about 2022, there was Monaco Explorations, had a program on the Indian Ocean where they go from Reunion and they go through Mauritius, Seychelles, Aldabra, and they do all the investigations and they do the surveys. And they they use the boat that goes down to Antarctic. There you go, the Agulhas 2, sorry. The Agulhas 2. They use the Agulhas 2, and they use that to do a 2-month scientific exploration to go down. They had scientists on board, they had divers on board, they had the 2,000-meter, our 2,000-meter Cougar XT on board, and it was a program to go and explore. And it was really a very good success. They were very happy with it because in Aldabra they could get right down to 750 meters, which they'd never done before. And with the ROV they could do a lot. But they caught fish, they processed it, and it was a whole scientific exploration. So basically there's a bit of a write-up, and I'm not going to spend too much time on that, because if you go explore it, you will find the papers. There'll be like 100 pages of what they found, but it was very good. But part of what I want to show you is that same ROV that's busy doing the same ROV that you saw now with the big 3D camera system for 3D dimensioning. There it is there. And if you look at the tools, and this is what we're saying about the effectiveness of what you can do in your mind. So if you look over there, that's the very same ROV, okay? One of the manipulators have been taken off. These here are boxes or tubes that we manufactured ourselves. That you would open it with the manipulator, you would pick up a sample, you would put it back in there, and you would close it. So that you could do all just on that. That pipe over there is in actual fact a slurp gun, which would suck up stuff. Another thing that these ROVs can do if you're doing effective surveys and scientific approaches to things. So So you can see we have all of those there. We have the slurp gun on there. And you can adapt the ROV to whatever you want to use it for, whether you're doing a survey on pipeline stuff, you're doing a survey on change, you're doing a full scientific survey. This was a huge project at huge cost. I mean, there's a picture of Prince Albert over there sitting next to Egan, knowing that the responsibility is his of the ROV, and he's busy flying the ROV that's in the container, because they underwrite the whole operation. So he came out and he wanted to see if he could fly an ROV, which I'm told he was quite good at. Okay, if we go a little bit further, you can look at the work class ROVs. So this would be a Schilling ROV itself. Your depth rating between 3,000 and 5,000 meters. Okay, weight in air 3,600 kilograms, and dimensions approximately 2.9 by 1.7 by 1.9 meters. Okay, and it could carry a payload in the water of between 150 and 250 kilograms. So the previous job that we saw, that Monaco Explorations, their ROV that they'd used on the previous one was an ROV similar to this. But they did not want a big work-class ROV because it came with its own problems. So they asked us to take the Cougar and modify the Cougar to do the same work. Hence where I get back to, it depends on your mind and what you feel you can do with it, and you can change almost anything. So big ROVs like these, there's the Schilling arm that I spoke about, the one over there, the Conan, and that would be the slightly smaller one. But with these, you can do all the inspections, you can do all, they use them for scientific approaches. Okay, there's a big ROV, it's much bigger than this, the Curve 2 and the Curve 1. Those were used to go down to the bottom of the Mariana Trench, and that would be close to 11 kilometers deep. Okay, no divers, except that guy that had that little thing that imploded, would even think about that. So you can use ROVs to go down and do your research at the bottom. Okay, that would be another one of those bigger ROVs. This would be a sort of a 7-ton or 7,000 kilogram ROV. And this ROV actually played quite an important part in South Africa in terms of the cable, the fiber optic cable that runs around Africa, the one we get all our internet on. So this Hector 4 was part of the operation to actually find the cable, look at it, see if there's a problem, help recover it, and then put it back down and then bury it in there. And with that, make sure, survey it afterwards to see that the seabed is all good. Okay, that's quite an interesting operation all on its own, but I don't think we've got time to discuss that. But if you have a look at that, for terms, that section on the top there, that's to locate an underwater cable or underwater metal. So that's a TSS 440. It will fold down in front of the ROV, and as you're going along, it will pick up any metal at the bottom. So you'd be surveying for metal, you'd be surveying for the copper underneath there. It would find the actual fiber optic cable, and then you could put that away, and then you would have your tooling in the front. You would also, if you needed to pick that cable up and bring it to the surface, you would be able to do it with that, and you would even be able to cut it. It would have a 10,000 PSI cutter on it. So all of that would happen with this vehicle, with this ROV. You can see it's quite a bit bigger. The payload is 650 kilos. So there's a lot of equipment that can be put on there for survey, for tooling, for almost any function. Right. So we've moved forward to the next class, which is the towed and bottom crawling. So this system over here gets towed behind a vessel, and it's quite it was state of the art when it first came out. It's a focus system, and what you would do is you've got an aileron there, an aileron over there. So it's like a wing of an aeroplane when it wants to go. Are we out of time? 5 minutes, okay, cool. So with that, you would tow it behind. On there, you would have sub-bottom profilers. So De Beers had one of these. They would have sub-bottom profilers which should go 15 meters, 10 to 15 meters under the seabed, that it could explore. sorry, over there, you've got side scan sonars, which would map the seabed that way. So as you towed that, you would be mapping the seabed on each side, and you'd be looking at what's under the seabed. And with the ailerons, you could move it from side to side. Okay? This over here is similar to the previous one I showed you, the 7,000 kilograms. It would be there for burial as well. So that would be a crawler. And then if we very quickly go here, you might recognize these. These are underwater crawlers for mining purposes. These are beasts of machines, approximately 300 tons. You can see, look at the guy standing there, doesn't even come up to that. 8 by 8 by 27 meters. That's a very, very old one. That's a fairly newish one. And that's happening off our sea coast right here on the west coast. Okay, autonomous. So we spoke about the autonomous. This is another one. It's a Seahorse class. Totally programmable, independent. Launch it. It will go away. It will do all the survey you're wanting it to do. The computer controls it, and it will do whatever you want it to do. When it's finished, pop back up to the surface, and all good. So you can see the size of that, almost 5 tons, 8.7 meters. These are ones locally. These are De Beers own these ones. They have 3 of them. So they rated to 900 meters, 1.5 tons, 4.2 meters. Same thing with that focus that I showed you earlier that used to do the survey of the seabeds. It's all in here. So you've got your side scans there, you've got your sub-bottom profilers there, you've got other equipment in there that's very fancy. And same thing, they program it, they let it go do its job. And because it's not subject to the ship moving up and down, the resolution on that, on a 150-meter deep survey, is down to a centimeter. It's phenomenal. And if you go look at the De Beers records, it's just unbelievable. So they have 3 of them. That's one of them been launched in Simonstown. Occasionally they do go wrong, but that's a different story. Okay, just very quickly, just to summarize, these are what we can do with ROVs, from diver support to mining, to surveys, inspections, construction intervention. Your mind is the only thing that stops you. And if your mind is active, you can do almost anything with an ROV. Okay, and to conclude, with the ever-increasing requirement of enhanced safety in diving, time constraints, and the need for sophisticated and accurate data in surveys and inspections, ROVs and their technology have become the cornerstone in delivering effective and efficient results in the underwater industry. That's us. Thank you. Hopefully we didn't run over too much. Cool.
Thank you to Barry and for the very informative, sorry. Barry, what did you do? Yeah, okay. We're going for our last speaker, all the way from the United States of America. Welcome to South Africa. It's Mr. Tony Greenwood. He is currently the Chief Executive Officer and Principal SME of Diving Safety Management Services and the residing CEO for Skill and Depth. For over 3 decades, he has served in commercial diving and oil and gas businesses. Tony started his diving career in 1989, serving as a U.S. Navy EOD diver. After attending commercial dive schools in the U.S., he worked as a construction diver and diving supervisor with a significant background in surface, supplied, and saturation diving. After working for 18 years with Stolt Offshore and Carl Dive International, Tony served as a diving critical activity specialist from ExxonMobil Global Projects Company, where he led 54 inland and offshore diving projects and helped to deliver 18 capital projects with a total value of more than $24 billion. He was responsible for the diving and marine construction contractor technical audit and approval programs. He conceptualized, designed, and led the Diving Center of Expertise, employing 45 staff managing diving activity across 5 ExxonMobil operating companies in 20 countries. For 11 years, Tony served as a vice chairperson of IOGP, Diving Operations Subcommittee. He is a member of several international diving standards and regulators forums, and from his position in the IOGP, he initiated and led an expert group that revised and updated the Code of Safety for Diving Operation for International Marine Organization. Tony will be talking to us about digital dive logs and competency system, the advancement in going paperless. Round of applause.
Thank you very much for that great introduction. It's really nice to be back to South Africa. It's been a couple of years, I think 2018. I appreciate this very much. I've always been impressed with the amount of professionalism for the great people and the companies that I've worked with over the last 20 years out of South Africa. So thank you very much for, again, another opportunity to speak and share with you. Oh, you already got that. Enough about me. I'll speak to you a little bit today about the company's skill in depth and what we've ventured into here recently as a way to bridge the gap on digitalization into diver logbooks and linking that with competence. Skill in Depth is a digital skill verification platform utilizing blockchain technology as a way of ensuring competence and experience history capturing for the occupational diving and marine industry. I think what's important to go through a little bit is to understand just a little bit about what the role of the logbook even is. It's fantastic to stand up and listen to so much discussion about technology advancement and where we are as an industry, but having to reach all the way back into the very beginning of our roots and understand that we still walk around with a paper logbook as a way of capturing our skill and expertise. It's time that we revitalize and enter that realm as well. The role of the current logbook is really used as a personal portfolio to demonstrate the overall competence of a diver or any worker really. And I'll speak a lot about the diver as it relates to a logbook here, but we're really speaking about all dive team members and really all workers in the marine industry or anywhere which uses logbooks to capture their skill and their experience. But it also serves as a legal record to a worker's training, their medical fitness, and their experience. Employers use it as a method to measure the worker's ability to perform specific tasks and activities. Certification agencies utilize logs as evidence of an experience needed to issue certifications, like the Department of Labor does. Clients often require logbooks as evidence for contractors' personnel as well. This was one of my roles for so many years with ExxonMobil, was to validate and verify the skill and experience of all the workers that were placed forward to work on our projects and programs. It takes a significant amount of effort to go through that assurance process. So diving contractors might be 4, 5, 6, 7 contracts removed from us, the ultimate worker. And at the end of the day, it is our work site and our liability to make sure that workers are properly trained and qualified in order to do that activity. So there's a lot that goes into a logbook if you think about it, just from its traditional role and what it's expected to do today. We can't really talk about a logbook without really understanding one of its primary purposes, and that's as a way of capturing and demonstrating competence. We had a great presentation earlier today. Jacques, I think, did a really good job at going into what competence is. They lended a lot to what organizations like IMCA,
the Department of Labor have already identified as competent, so I don't think that we have to go through that too much. But I think it's important to understand the important aspects of where competence and skill and experience gets captured inside the logbooks. Back to defining competence a little bit, we have a measure of skill, knowledge, and experience. The ability for workers to perform a specific task or an activity to an expected outcome. Some of the things I think is interesting in our sector of industry, and that is when we define competence and we apply it, do we apply it too broadly? To say, is a diver competent to do an underwater inspection on a pipeline? Well, that could be made up of many, many, many tasks and small activities and utilization of tools, as we've seen today. So how finite do you have to go to assess somebody's skill and knowledge to be able to complete a task? Well, if that task has 27 different tools and 15 different environments and lots of other things, how finite do we have to go before you can determine that this worker has the skill to do the task that I'm going to assign them? Employers, industry associations, and clients have competence schemes based on industry needs where diving is employed. You know, diving is an activity, as we know. It's a way of getting to a job site, but what are you going to do when you get there? The energy industry, such as the oil and gas and marine renewables, salvage industry, civil construction industry, public safety, they all have their definition of what competence is based on the application of diving in those spaces. So when we say that our diver's competent, remember, diving is just it's a method of getting to the work site, and it has its own inherent risks and competencies that's required to do it. But the application of diving is something that I feel, and at least in my experience, is often missed in the competency space. And obviously, we know that a dive team member lacking any specific skill or experience required to carry out a work task, it can be critical, and it can lead to inefficiency, injury, and unfortunately, as we know, fatality sometimes. So I think that this is the important place to understand going forward how competency has to relate to logbooks and how we digitize and what our efforts are from here going forward. The challenges in our industry related to dive logs and competence is probably why I'm standing up here talking to you today. Over the last several years, a lot of the industry forums that I've worked with and in my personal position at the company that I was at, we had a significant recognition of fraudulence in our industry. And I'll define that a little bit. In addition to fake diving certificates and altered dive logs and really embellishment of one's skills on CVs and things like this to be able to gain employment, we recognized and had experience that this was a significant contributing factor to many of the industry's injuries and fatalities. So much so that you know, inside of an organization, some of the large oil and gas producers, especially, where they really have a significant risk tolerance in a lot of ways for what they do. The mandate for a lot of oil and gas companies is to engineer out diving wherever you can. It's looked at as an extremely critical activity. And a lot of times just the work that the divers are performing, where they're critical enough, now another one of the risk profiles is this a competent person and is it real? In today's artificial intelligence age, we see perfect replicas of diving certificates, training records of people who have never been in the diving industry a day in their life can produce an amazing portfolio of competence and hand it right to you. So there's a lot to be said about counter artificial intelligence and being one step ahead of and smarter than those out there that gain their employment and their experience through falsehood. Some of the other challenges, divers and other critical personnel just simply lack knowledge, experience, and skills needed to perform an assigned task. Not to say that they're incompetent overall, but perhaps they don't really have the knowledge and expertise to execute that one critical activity. Perhaps it's working 5 meters below the seabed in a mud-caked ditch, or placing a 250-ton load on the seabed using a crane. Could be anything. Simply saying that I'm competent because I'm a diver is not the right route. Current paper-based logbooks do not allow capture or display of data to show a worker's ability with adequate details. Certainly, if we articulate very well how to write in your paper logbooks, it is still paper. And so to transfer paper from you, the origin of the worker, and to get that through the employer, the agency, to the client, we're just really challenged by the information, the speed of which we can get this information across. Fraudulence. One thing I'd like to speak further about this, and especially with great respect to the Department of Labor for South Africa, recognizing this challenge in our industry, very proactive at taking steps and measures to try to reduce this as much as possible. And what we've seen as an industry is everything from a valid diving certificate, for example, issued by the authority, which then goes off and is altered or doctored by somebody with scrupulous intentions. That's very hard and difficult for the authority to manage. And on the other side of that, divers who legitimately, or workers who legitimately gain certification through providing fraudulent information to the authority in order to gain the certification. This is something that has always been probably inherent in our industry to some degree, but as the technology has advanced for us, and the communication and the networking through the associations to check this data, it reveals a lot. And it doesn't just end with certificates. It goes on to diving medicals and past employment with other employers where this is claimed as on the reference of CVs. Paper-based data collection prevents and complicates and slows the information transfer. And then personnel just simply not using the logbooks to their capacity. It's an activity, right? A lot of people are just lazy to do it, or I'll get to it a little bit later. And as time goes by, of course, the detail and the accuracy of the data that goes into it can start to be compromised. And then, of course, having all of these things and not having the supervisor's signature or the means to have the verifier be available to do it, at the end of the day, you end up with a piece of paper that has a certain amount of data on it, and this is supposed to be a reflection of one's capability and competence. And of course, the dreaded diver losing of the logbook, whether it's your gear bag over the side of the vessel or you hear it a lot in the Gulf of Mexico and Louisiana. Divers are often affected by hurricanes, and we've had divers' entire careers get wiped out by a simple hurricane coming through and flooding their homes and taking all that away. That's a real thing. So why digitize the logbook? Well, if that wasn't enough reason to explain why we should digitize it, I think digitizing allows us the opportunity to mitigate the deficiencies experienced with the traditional paper-based system, and it creates a host of new possibilities that can enhance the personal logbook experience. The case for digitization? Well, it's not much of a case, really. It's usually asked the question, why would we not doing it? We're doing it to everything else. This isn't cutting-edge technology to digitize something. I think it's just applying this in the appropriate places now. Mandatory requirement, why the logbook? Why not just come out with an entire new system of digitalization? Well, the logbook is already required by law. It's already a statute. Why not modernize it and make it do what it's supposed to do anyway? Why have a paper-based logbook system and then some kind of digitized system as well? It just adds administrative burden, and it adds redundancy where you really don't have to have it. It makes a good case to just go ahead and digitize and advance the technical capabilities of your current legislative logbook. Efficiency. Efficiency is everything, as we all know it. Just the ability to move the information faster, keep the information accurate, and really by digitizing, you just open the opportunity for so much additional analysis of data. something that can take you long periods of time to do. Any of the divers in a room, of course, that at the end of 200 pages of a logbook have to collate all their time of how much bottom time they have. Having to sit and crunch all the math is just kind of a pain sometimes. So digitizing makes a good sense in that regard. And of course, we can always stand on the environmental benefits of paper reduction. Yeah, I think that's important. Probably not a large-scale activity, but it's certainly, I think, another case for the digitalization. So some of the benefits, the potential benefits for a paper-based, or I'm sorry, a digitized logbook replacing paper-based systems. Well, we've already mentioned, of course, the speed and efficiency. Standardizations of skills and terminology, I think, is something else that's really important. Anybody, especially a diver, writing into his logbook that on this last dive he inspected pipeline. You know, there's a lot to be said about what you did in that pipeline inspection. And probably somebody else can recognize and understand what that means. Well, he probably also had to excavate to get access to it. He probably had to use some kind of a cleaning device to gain access to the parts. But did he do close visual inspection, general visual inspection? Did we do non-destructive testing? Did we have to remove pipeline weight coat to get to it? Did you have to excavate inside of a 3-meter ditch and use airlifts and excavation equipment to execute your pipeline inspection? The amount of detail that we should be logging into our paper-based systems do not really reflect this level of activity. The digitalized system offers the benefit to really standardize this and use a commonplace that we can all recognize with some of these skill and activity standardizations. Improved data accuracy, automated data validation, and real-time feedback reduces errors associated with manual entry. You know, again, anything that we can do to reduce the burden for already extremely burdened work sites with administrative needs gives us a good benefit for that. Enhanced fraud protection prevention, probably one of the main reasons for doing this as well. Digitalization offers a lot of benefits when it comes to fraud prevention. It has its own that you have to concern yourself with. We'll get into that a little bit. But that, again, is one of the tremendous benefits of digitalizing. Ease of data sharing. An example of this, of course, is as I had a $500,000 to $600,000 a day diving support vessel standing by to mobilize at a dock, only to have 3 or 4 personnel not be able to make the plane flight to come into country. And suddenly we're scrambling, trying to find divers and marine crew to fulfill those roles, and we're standing by our inboxes waiting on photocopies of PDFs of dive logs and certificates, and it's just, that's not our age anymore. You can imagine that this is an extremely frustrating thing to have to deal with in all regards, not just as an end client, but I always think about the staffing coordinators who are under the crunch at the last minute at 2 o'clock in the morning to get this data. It's just, we don't need to be there anymore. Obviously, the reduction of paper, and then the prevention of lost records, I think, is just another one of the key benefits. Digitalizing is fantastic, but it doesn't come without its own potential challenges. Kind of go through a couple of these here. Probably first and foremost is just data protection. This is the age we live in today, that stolen identities and malware and just about anything that you can think of out there to steal the personal identification and history of people is certainly, I think, at the top of everybody's mindset, especially when you consider that you may have occupational documents, maybe medical information, things like this, which are traditionally carried in logbooks, is now something that needs to be considered. Again, we talked about making sure that you know, paper logbooks and things like this are fallible and fraudulent. Well, certainly data protection can be stolen, data can be stolen, and the same thing happened there, but we have to be very diligent about how we protect that. Competing formats and data entry requirements causing users to need several systems. We've seen this many times. How many different driving applications do you have on your phone now? How many different maps? As everybody starts to put out new things, you know, we have the potential concern of maybe the occupational workforce having to have and carry too many applications that do the same thing, and they're competing, and it doesn't work on the same network of something to this degree. Certainly something to consider. Sensitive work sites not allowing digital devices. This does come from time to time. Just as security at some of the work sites don't allow personal devices, or they restrict access to personal devices. So I don't think it's something that can't be overcome, but it's certainly a consideration when you think about the real time of entering this data. How are you going to do that? In some of our early beta testing, certainly culture and resistance to change is always the biggest one. Yeah, here's just something else I got to learn now. Amazingly, of course, 35 and under, no problem. You know, my 16-year-old daughter, just like that. You know, a 56-year-old diving supervisor like myself who just shakes his head and says, another app that I've got to deal with. Well, it comes around when they start to realize how much time that they save by not having to do data on paper some more. It starts to take hold. And then really, another one that's important, and that's the ability to incorporate existing paper data. If you think about a diver, any worker who's got 10, 20 years of information already stored in all these paper logbooks, how do we get a hold of that? How do you mine that information and bring it into the digital platform to allow it to go towards the credit of the worker? Something else that is a potential challenge but has also been solved. So what kind of minimum features and capability should an electronic logbook maybe have? Bless you. Well, much of the same that your paper-based program was meant to have. You know, it should be a document portfolio for training, education, medical fitness evidence. Dive records or work entry records. Again, we're talking about divers here a lot, but ROV personnel, crane operators, marine personnel, anybody who uses a logbook, the digital logbook concept works the same. The work record, or the record of work, or in this case, a record of dive entry form, which incorporates all industry minimum standards. Like any great logbook that's out there, they all have about 80% common information, but about 20% specific maybe to the legislation or the industry of which it's supplied. I think the featuring should allow the incorporation of all formats. So that, again, we're not duplicating or making competing systems. Electronic and digital signature endorsement methods, critical, critical, critical. End users who read logbooks make determinations on how authentic they are and if they're willing to accept them or not. Myself in a position of authority when I could look at that logbook and I could say, I'll take that one and I'll take that one, but I don't like that one because it's missing a signature. This one's got a funny looking rubber stamp. I mean, the end user is really the determining factor on the authenticity of the record. In this case, of using the Department of Labor, they themselves have the determining factor on whether they're going to allow the acceptance of those particular records. The digital and the electronic signature is critical in assuring at least a particular level of authenticity. Otherwise, it's just somebody writing a bunch of things onto a record sheet and saying, I did this. Traceability and digital fingerprinting of data entries and endorsement. This is something that we recognize as very valuable in the cases where we're trying to authenticate that something is real. Think of your DocuSign today. You sign bank documents, you buy homes, you sign contracts for life insurance, and you do this all digitally. Why would you not apply the same technology to something like skill verification in a critical role like diving? Ability to work online and offline internet connections. Our work sites are remote. You really need to be able to work these things in an offline mode as well as online. As great as the technology is that we are deep offshore, to be able to have connectivity, the simple fact of the matter is these communication systems are going to be failing from time to time. The ability to incorporate the experience and records from the previous projects, as we've mentioned. Capable of integrating regulator and industry association competence schemes. This, again, is something I think is very important. The International Marine Contractors Association, the ADCI, many, many different organizations Some of the clients have their own schemes that they say are required if you're going to do work on their behalf or receive certification. Digital logbook systems should be able to incorporate and accommodate these types of schemes. Network interface capability, API. It does no good for databases to not be recognized by each other and to share data. Otherwise, it's data in a silo. User data and identity protection measures to meet the general data protection regulations of say, Europe and United States, and of course, PAPIA here in South Africa with the Protection of Personal Information Act and national regulations is absolutely critical. Absolutely critical. To create these systems and not have data protection in mind, especially at the regulatory level, is really a non-starter. You have to take this into consideration. And then allow audit and assurance of system integrity by authorities and third parties. Everything that we do today, if we audit our current competency systems, you would expect nothing less here as well. These digital systems have to be auditable, and assurance has to be incorporated into the system to allow authorities and third parties to do this. And probably the biggest one that I missed on here that I think is important is just make it user-friendly, make it easy. It's very easy to complicate these things and make it to where people can't use them. So if you want them to use it, it's got to be easy and it's got to be usable. Skill in Depth has achieved a significant level of success creating a proficient digital platform for capturing and validating the skills of occupational diving industry and the marine industry. Our accreditation and partnership with organizations like the Association of Diving Contractors International, several international contractors such as Oceaneering International, Divers Institute of Technology, Mermaid Subsea, and ExxonMobil, is a testament to the advantages of a network-based skill verification system. Our technical contributions into digital logbook system concepts was instrumental into IMCA's C019 Principles for Data Platforms and Work and Skill. If you'd like some more information on Skill in Depth, please use the QR code that you see here or grab me after the presentation. Thank you for the time and opportunity to present to you guys. I thank you very much.
Thank you to all our excellent speakers, and they've really saved time for us. A round of applause to all of them, please. Now it's time for questions and answer session. Can I see by the raising of hands who's got questions? 1, 2, 3. All this side. I already have one question from our online participants.
Who's number one?
This one is for Peter. I'm just going to read it. You can note it. The question comes from Andrew. It says, my question comes more from an academic point of view. Funding and resources are scarce and difficult to obtain, specifically for ocean-based research. Instrumentation is costly as a large portion is imported and not locally produced. Add to that the cost of hiring contractors to conduct work and meeting requirements such as minimum manning requirements, personnel qualification, and training needs. For an example, training commercial divers up to actually be competent in scientific diving is subtracting both financially and time from already stretched and limited research projects. How do we bridge this and ensure the continued advancements of the marine industry while not compromising safety? I hope you've got that. The second, sorry, you can just note them down so that we recognize.
Okay. Hello. My name is Colin Levine. I'm from Oceans Alive Conservation Trust. It might seem a bit strange that I would ask these questions, but mostly around the scientific, I think Peter was talking about scientific diving. There was notice given about lost instrumentation and commercial divers that are not capable. We've got two issues that we find. So as a conservation organization, we can't reach communities and they don't want to listen to us unless we are giving them training and we're creating jobs. They don't want to listen to us talking about plastic pollution, wildlife. They don't care. Their whole idea of life is to get through the day and put food on the table. So we have got an academy where we train people. One of the things that we do train is commercial divers, lifesavers, rescue, all types of things. And we're finding that about 2-3 years ago, millions of rands were put into training recreational divers, which really irritated me because those people today haven't got jobs. They cannot work without a commercial license. We all know that. But in terms of the scientific diving and the instrument loss and various things, there are still today many, many recreational divers that are doing work that they shouldn't be doing. They are working with instruments. They are trying to do rescue work. They're cleaning the bottom of boats. And that's something that we've got to look at as a country as well as around the world. Coral restoration diving, there's people around the world that are doing it just on recreational license. So where does it come where we say you cannot do that work without having a proper commercial diver's license? We've trained in excess of about 100 commercial divers in the last 2-3 years. We don't only want to train them, like unfortunately many schools, they certify them, class 3 or class 2, and off they go and they've got to get a job. These people need to have extra help. They need to have hours. They need to basically be assisted with CVs. They need to be able to be assisted with connection to employers. So where we're having an issue at the moment is that it's not good enough anymore for the school just to give them a certificate and say, you are now a commercial 3 or commercial 2 diver. We need to be able to say to the schools, you must bring into that a conservation component. And everybody here, conservation, our world is going to hell. And we need to do something about it. So we train commercial divers to give them a conservation, idealistic approach to looking after and saving our world, especially our oceans. And most commercial divers have traditionally been going towards oil and gas and other industry. So we got a lot of divers that are working with the aquariums. They are working with scientific equipment. And I think a question to Peter is, we need to know what you need so that we can train our divers to be able to work in science better. For instance, we run a project in Knysna called the Knysna Seals Research Project. And that project, we've got 10 commercial divers in the water, diving 4 dives a day at 3 meters only. It's very shallow. And those divers look for seahorses. We assess where they're living, their conditions, are they being upset about noise. So that's research diving. But before we can put them in the water, we have to train them to do transect diving, because they come out of the school and they don't know how to do that. They don't know how to work with instruments. So I would appeal to anybody here that's interested, tell us what we need to train the divers in so that we can include it in the curriculum at the schools and try to give these divers more opportunities, because we want more divers working in conservation. We have a lot of our divers also working in or trying to get into police search and rescue, our better divers, and those people also, what do they need to get into police research and rescue? So we need to try and work together. And so I think talking about commercial divers not being competent to do scientific diving, it's because we haven't shown them what we need to do. We haven't taught them how to do it. And most people that are doing marine biology or learning to be scientists, they only come at last minute to get a class 6 or a class 5 diving certificate so that they can go and do what they need to do. So my appeal is that we should try and first of all stop recreational divers from doing commercial diver work, because that takes away work jobs for our people and for general commercial divers. And we should be able to start giving them more skills like transect diving and other research diving so that they can do their work.
Thank you.
Thank you very much.
I'm happy. You come with a question, a recommendation, and an answer. Peter, can you respond to the two questions before we continue?
Yes, it's actually quite simple, but it's also not that simple. It's a long problem that we do have, and he's actually hit the nail on the head. The difference in South Africa versus the rest of the world is that in South Africa, legally speaking, you need a commercial qualification to do work, which includes scientific work. The regulations is there. The fact that we've got sports divers doing work, we can't do anything about that as the industry. That's something that our authorities need to look at. We've been trying for years, and unfortunately worldwide, in Europe, that is what they do. Scientific diving gets done by people with PADI CMAS certificates. I'm sitting now on an ISO committee where they are writing scientific ISO codes for scientific diving for sports divers. That comes from the EU. America, they use sports divers. Europe use sports divers. For a long time, England used sports divers. Australia, some of the universities are still using sports divers. South Africa is one of the first countries in the world where we said as scientists, and that actually came from my predecessors, that you need a formal commercial qualification or scientific diver qualification to do scientific work. So scientific diving in the country was first regulated way before commercial work was done. So yes, it is a problem, we know about that, and it's a discussion that we can talk about a long time. But yeah. The other issue that the other person brought up, and links in with this one. So we as a scientific community sits with the problem where money is the issue. And now people are using shortcuts by, instead of employing scientists or commercial people, they are going the sports diver route. And this is where the citizen scientist comes in. And I get daily calls from, call it research organizations. They're not really research organizations. It's people, yeah, I don't want to offend people, but a lot of it comes from scientists that's creating their own companies and getting funding to use sports divers, and they bring them in from overseas, and they do all kinds of things with them, and then they call them citizen scientists. So it is a problem that we do have.
Thank you. Is it a follow-up? Oh, okay.
Competent for that one. So if it's okay with the department.
Okay.
Let me start off by moving to the term sports diving. We're not in the environment where it is a sport. I think that is the first part of it. It is very clear that there is an offshore component and there's an inshore component. It is very clear that there's definitely challenges in wording and terminology and the utilization with that terminology in the different sections. We do not operate offshore. Our law prohibits us to move further than 12 nautical miles. Anything in 12 nautical miles falls within our law. For me, as a police officer in the South African Police Service. So when we are looking at 12 nautical miles, you won't find us there because we won't go that far. We're dealing with anything in and around our shoreline as far as possible, and all mostly inshore. The sport diving equipment that we are utilizing is being utilized to perform a function that relates to a work environment. On your question of joining this function, I need to put it in context. Yesterday, there was a presentation done, and it was noted by one of the speakers that there should be a warning being put on it. The work that we do requires from you to belong to the South African Police Service, and I mean it in that sense. You belong to the police. You're not working for the police, you belong to them. Because they will take your best years, and then when they are done with you, they will put you in a chair and you will retire. Because your mental health suffers tremendously. We're dealing with the challenges of extremely badly decomposed bodies and horrendous scenes, of which the worst is females that's been raped and murdered and thrown into canals, and then fetuses and small children. That is, for us, the worst. The others we don't cope with it, but we learned how to work with it. So if we develop a police diver, the person has to be in the police service, appointed under the Act for at least a period of 2 years. Then we go through a selection process. Our challenge that we are sitting with is that this environment is excessively expensive. So to put it in perspective, the state is our contractor. I service in the Western Cape 152 police stations, which I have to respond to within 4 hours. And then we have to do a function. Most of the times we arrive at night, 24 hours, 7 days a week service. And then we have to do a scene and recover a person. So we always email or send messages to the dive inspector saying that we're en route for a police incident or scene. The challenge is not to train the person. The challenge is that if you have trained the person and the person might join as a reservist into the police if we have a position, there must be equipment procured for him by the taxpayer. And it becomes a serviceable item that has to be serviced every year, which puts cost on the state, and we have to manage that within the PFMA Act 1 of 99, and also take in consideration cost containment measures. So the short version is that's the first problem. And the last problem is that a person that recovers a body must provide a statement. And that statement will be forming part of an inquest docket. And when it is in the inquest docket and that docket goes to court, that person will be summoned to come and testify in court on what he has or she has experienced in the process of recovering for the line of testimony for the purposes of the Inquest Act. So we would rather, the teams are small, and they're small for a reason. And we believe that it is important that people are aware of the function, and where they can help, we will take all the help that we can get. But the challenge is that we are under the Department of Manpower. We are very much protected. Is it not Manpower anymore? Did you change your name again? No, man. Okay. So under the Department of Labor, Director General, I can't keep up anymore. But anyway, so to put it in perspective is that at the end of the day, if the way we are regulated, everybody of us, sports diving is not. And we have fatalities there as well. So then other acts then that gets into place. So the long and the short, I would not suggest that a school train a person in police diving, perhaps have a session on it, on the role of a police diver and the function that it does. But I do agree that it's a good starting point for development in the scuba part. So if that answers the question. Sorry for taking so much time.
Thank you. Can you have your interaction maybe outside this meeting? Thank you. There's a from SAMSA and then Bridget. If there's a mic that can go to.
Thank you.
Can you hear me?
Azumbavi Normondo from the South African Maritime Safety Authority. I'm going to be trying to be short. I've got a couple of, first a comment and maybe a suggestion, because I think the part of the challenge maybe with what has been termed recreational divers is that, and this is the experience of SAMSA, is that when you regulate by silence, so, and I don't know if the Occupational Health and Safety Act has a specific definition and requirements for recreational divers, and therefore that they have to comply with, because you have to deal with their standard. If they are completely silenced, it becomes a game for everyone and no one, and therefore it becomes dangerous. And that's why the National Small Vessel Regulations actually created rules for recreational boats. So you can go do whatever you like, but here's the rules. So if we find you transgressing these rules that you ought to have known, and maybe that's something the department need to look at. And maybe to come to the questions directed to Tony, I think it's the issue of digital documents and records and things like that is something that greatly interests us, because it's one thing in the marine space as well. Seafarer record books, certificates of competence, same issues of fraud and forgery and fraudulent activities are something that we also grappling with. And I think without much knowledge about the diverse logbook, and I'm going to talk about it from the seafarer's record book, that ordinarily that record book belongs to that specific seafarer. At the beginning and end of an assignment on board the ship, the master of a ship would make an entry that from 1 January to 31st of March, this particular seafarer was on board in this rank, and a few other items that they would need to put on that record. And as an administration, when somebody presents that for certification, it tells me, it's 3 lines, but it tells me 1,000,000 words about what the person did. And now, my questions around it is that, so who should be the producer of an e-log book, or as you've suggested? So in South Africa, I've got seafarers who work for any number of companies on any number of ships from any number of countries that you can imagine. And should it be, in this case, SAMSA who produces the book and say, every seafarer, you're going to have an app, and when you get on board, should we expect the master who comes from Ukraine to be able to complete that on a Singaporean ship hired by a Canadian company? It's a complex environment for us to try and imagine, and I'm hoping that you can help with that. And if you imagine on a South African ship, this is the other perspective, you've got, SAMSA would have the primary custodian of ownership, but on the other hand, you've got a South African captain, Ukrainian chief mate, a Filipino second engineer, and an Indian fitter. And where should this app or this record sit? Because now all of them wants that record to go and be able to use it at their home, when they're applying for the next job and things like that. So just if time allows, maybe just try and unpack it a little bit for us as to how would it work?
Just briefly, you can have other conversation outside this meeting. Just summarize the response.
That's exactly what I was going to recommend. There's a lot of discussion there, especially if you consider the Siemens book as well. So yeah, be happy to meet with you and share with you what some of those potential solutions are for something like that.
Bridget?
Thanks. It's also for Tony. Thank you for the presentation. I'm Bridget from the Academy of Diving and Offshore Medicine, and I'm thrilled to see that we're launching into an era of non-paper. So in 2017, I presented at the IMCA conference in Singapore regarding the DMT competencies. So I'd be interested in having a look, yes. And even though I got banned for a little while for going paperless, we are all back on track. And actually, what I've done now, because I have a training school for divers, and we also see that there's sometimes inaccuracies, difficulty with logging and actually teaching logging. We've currently partnered with a South African company that offers a digital logbook that then will ensure the transparency and the progression of students before they enter into industry. So I'd be quite interested in speaking to you about that and the linking of the DMT competencies.
Thank you. Okay, there is a follow-up question to Peter, but I think it's more for the department to respond to the question. It says, follow-up to Peter, should consideration be given into creating a subcommittee for scientific/police diving that can feed into the commercial diving committee?
We've actually been talking to all emergency personnel to develop a code of practice to address these specific issues. Because on the method of diving where you have a concern, but all other aspects of the regulations apply. We already have an established committee, so having a subcommittee is an issue. But the regulations allow for a special competency to be co-opted. So having a subcommittee will have additional financial implications. Likely you did quote PFMA. So going back to PFMA, we can make a submission, then the council can advise the chief inspector, these matters we look into like this, but we need to present what we've been asking you to present. Thanks.
Thank you. One last burning question. Oh, there's one. Last one.
My name is Nigel Janison from the Academy of Diving and Offshore Medicine. But my query is really about divers. DOL divers have no voice in the industry. They have no platform to talk about or to voice their concerns. And there's so much cost involved becoming a diver. And once you become a diver, you enter the market. It's a freelance, it's a looking for a job. It is from this one to that one. So my question really is the DOL and SAMHSA with the, especially with as far as the seafarers books are concerned, DOL divers are not considered seafarers. So we have to apply elsewhere, Panama, et cetera, for a logbook, for a seafarers book, which is a requirement for offshore diving. And the cost just becomes horrendous. It's offshore survival, it's passports, it's SSE, it just keeps on going. So you work from job to job, trying to make enough money to get the next offshore or the next DMT or the next refresher. Is there any platform or voice to speak for those silent divers out there? Because most of your offshore divers are away for 9 months of the year. They are probably listening to this conference and maybe monitoring it, and they have a voice that is not heard. So my question really is there a platform that can be created, an organization or an internship that will assist our divers, especially from impoverished areas? Thank you.
I've got my seniors here. But I think in terms of our laws, you can have an organized union that can talk on behalf of you. So I'm not sure if you can, maybe because you are not organized as a sector, but you are allowed to be organized, to have a voice. Yes. Give the chief inspector.
So, as workers, you have the ability to come together and organize yourselves in the form of a union. There are unions that are not recognized where there's a group of people that does come together and you appoint somebody that speaks on your behalf. So nobody is preventing you from doing that so that you are able to speak on behalf of whoever you are presenting. The challenge that we have, I think Ms. Huna and Ms. Mhlope will know, is that we have a challenge with, I'll make an example, with somebody that wrote to the minister that they are representing contractors, ne? They are representing contractors and there's a lot of issues that they are raising, but we don't know who they are representing. They don't have a list of those contractors. We don't know how they organize themselves. We don't want a situation where we have any Tom, Dick, and Harry that comes to us as the department and say, I'm representing who or this group of people. So you need to organize yourselves, appoint somebody, indicate to us that this is the 20 organizations that has mandated Mali writers to speak on our behalf. Thank you.
Thank you.
Samsa wants to
Are you
respond to this
responding?
also.
You are not asking. Okay, thank you.
Yes, and I think on the seafaring side, and I think the issue of the seafarer record book, what companies require, if they require one from a specific country, we cannot control that. And after our conversation 2 days ago, I checked about our seafarer record books. They're generally accepted the world over. We made changes in 2016. They should be accepted. But I do know that there is some employers who choose not to accept it, and we cannot force them, most especially because they're not South African. The second part about representation, at least in the seafaring side, is that we, SAMSA runs what we call the syllabus committee, and it's an open consultative forum. It meets at least twice a year, and anyone, you can come representing yourself, and you can speak. There's obviously rules. If you want the syllabus committee the seafarer syllabus committee to discuss a specific issue, you just need to submit it, and it's up for discussion. There will be questions asked so that everybody comes prepared. But I think any seafarer is welcome to those meetings at any given time as well. Thank you.
Thank you. Thank you for the questions. Before I ask the speakers to come and collect our token of appreciation, I just have 3 announcement. We request those who have attended online, if they are attending as a group, to please send us the registers so that we are able to know how many people had participated in this conference. Secondly, there's a request for all the speakers to assemble there at the tank for a group photo. Then also, colleagues, the stamp that they've given you is giving you access to tour the aquarium. So if you have time after lunch, you have an opportunity to tour the aquarium without any limits. I will then ask all the presenters to please come forward. I will then call on our Inspector General to do the closing remarks for the conference. Yes.
Good afternoon. Good afternoon. Is everyone well? I'm good too, but it's cold in here. I don't know if it's just me, but it's cold in here. But the company is warm. I just want to talk to some of the highlights. And obviously the highlights are going to be subjective because it's things that were highlights to me. If I was to call any other person, I'm sure your list of highlights are going to be different from mine. The first thing that sprung on me was the value of an effective health management system. I think several speakers spoke about this, to say that there is no replacement for a management system that is of value. Not just a tick box exercise or an issue of malicious compliance, but a system that is going to work, not only for you, but for the sector and for everyone around you. The second thing was the hierarchy of controls. I've known this hierarchy for a few years now, and the emphasis has always been that the last must stay last. The last on that hierarchy is PPE. And sometimes there's a tendency of flipping the triangle on its head, and PPE becomes the first, when it actually should be the last resort. So we can never afford to take shortcuts. The road that is littered with shortcuts almost always leads to one or the other kind of disaster, because shortcuts, most of them are never meant to be taken. The more time we spend on things that really matter, and the more we invest in those, the more we're likely to get some value for money in that regard. I also thought I should put the spotlight on the value of regulations or a legal framework that is viable, that evolves with the time. Ladies and gentlemen, we don't live in a perfect world. Regulations, policies, all those things have got their fair share of weaknesses. There's no way you'll come up with a perfect law. There'll always be gaps. And hence, we always review the laws. But one of the things that really sprung out for me was that we need to have conversations some more, particularly among stakeholders who are driving the same agenda. A case in point will be SAMSA and the department. And I mean, we can go beyond that. Let's just find some common ground. And we are inevitably going to realize some kind of a resource saving, because when we bring our efforts together, we do tend to add a bit of value in that regard. I think also there's somebody that spoke about the issues around psychosocial impact of the work that we do, particularly the police. The gentleman behind me, Captain, I heard your voice loudly and clearly. I don't know whether was it because of proximity or you're just persuasive by nature, or both. And he also has a way of twisting titles and names. I can't remember the last time I had somebody calling my department, the Department of Manekrach. The Department of Manpower. You know, one of the reasons we moved away from that name was, where's women power? When you're going to talk about the department, we moved away in the 80s. But I think on a serious note, you made me to appreciate that beyond every body that gets retrieved, there are real human beings that are doing that work. We've got emotions, we've got feelings. And over time, there may be something called desensitization, but the impact at a psychosocial level, it stays. It does stay. So we've got to have an appreciation for that. That with each body, a damage is being made. And it made me to have newfound respect for the work that you do. And I'm sure I'm not the only one. So keep up the good work that you're doing. There may not be cheerleaders alongside the routes that you take when you go to those sites. But the work that you're doing, it's of great value. Something also that I think we should really not lose sight of, because sometimes we come into conferences of this nature, we talk, we eat, socialize here and there, pack our bags, go home, and forget that we ever came here. But I'd like to see, Chief Inspector, real value. We need to hone in our collaborative capabilities. I'm emphasizing on this again. I know it's a cliche, but it's actually true that together we can do much more. So let's just be big on collaborations and partnerships. We can never be able to achieve any real change unless each one in the value chain play a meaningful role. I am South African. Ne? As South African as they come, I speak all the 11 languages fluently. I do. Read, write, speak. Ek praat mooi Afrikaans. Ek dink so. Ja, I do. Ndihamba Tshivenda xa Vukuma. Na vulavula Xichangani xi twakala. Ndiyakwazi nokuthetha. Ke a itse go bua ke nyetswe ke Batswana. So the kgomo tsa Batswana di tsile mo. I can go on and on. But I guess there's something that was said by the chief inspector that they send the hand and the mond, the pap, op the grond, val. Ne? It's also emphasizing that through the work that we do, paying attention to details and making sure that we close those cracks, it's a value add that we cannot run away from if we really take our work quite seriously. So it's a challenge. For me, it's something that I think we should really look at. Viable risk assessment, the issue of decent work, we spoke about that. And I did emphasize on the first day that when we gather in this type of gathering and this type of fashion, it's given that we're going to be repeating ourselves because we're talking about the same things. The strategy 2029, please don't forget, strategy 2029. Some of the things that I'm saying here are firmly embedded in the values of the strategy, the objective goals, and. I appreciated and understood issues around sheep husbandry. And I think it was either Bill, and Bill for some reason, when I read your surname as Clinton. It's got all the alphabets. But you broke down for me PPE. You said people, paperwork, and equipment. Appreciated that. And I want to say that life is never static. Change is certain. If you can be sure of one thing, is that there's always going to be change. The challenge is for us to be able to adapt. And as we adapt, we also adapt our strategies. We've got to embrace technology, whether we like it or not. We've got to embrace technology. There's more to be gotten out of innovative technology. I was told that I'm going to be the last speaker of the day. Now, in the South African culture, all of us put together, it's never enough to speak as the last person and not to thank everyone. So I want to thank all the speakers. I know that it takes time to put presentations together. Think about them, come stand here and present. So both local and offshore speakers, you did great. You did absolute great. Fanny Kruger, Mike Yusop. If I butcher your name, please pardon me. I'm trying to remember. Bill and Alan, Peter, Jacques, all of you. Even if I didn't mention you by name, please don't be offended. From Scotland, your accents gave you away. The first day when you spoke, I said, no, these are Scottish people. From Australia, we had a presenter online. From London, from the United States of America. Thank you so much. Thank you so much. And one thing I appreciate about technical conferences like this, I get to speak to men more than women. It's male-dominated. Serious. We had an attendee from Germany. I don't know if the gentleman's still here. From Germany. Are you still here? Thank you, sir. Thank you so, so much. And all those speakers that are not on the program, in the form of asking questions, Bridget, making comments, Captain, writing a mini thesis on the floor, impromptu. We appreciate everything. You really contributed to the success of the conference. To the organizers under the sterling leadership of the chief inspectors, guys, you did it. I feel like a mother hen, ever so proud. The venue is out of this world. I mean, it just dovetailed with the diving conference, bringing it here. That was brilliant. And you know what the magic is? They say if you want things to be well done, underline the word well, give it to women. But if you want them to be well spoken about, give it to men. So thanks. Thank you so, so much. And to our host, the Two Oceans Aquarium, thank you so much. It really felt like home. After all, South Africa is a beautiful place to call home. Thank you so much. A hands of applause. Now look at somebody who's sitting next to you and tell them, well done by coming here. Okay. Some went beyond the request. You were now having a conversation, but it's fine. And lunch is going to be served, ladies and gentlemen. We're also requesting that please remember the photo shoot, and the conference has come to a close. Thank you very much.